Good morning, ladies and gentlemen. This is Serena, your today's host for the conference. I'm a program manager at Platinum Global Solutions. It is a great pleasure for me to welcome you all to this Big Data Innovation Conference 2021. Thank you all for joining this virtual meeting, and I hope every one of you enjoying their best health. Whether you are attending this event for the first time or you have been a part of our top-notch conferences before, I'm sure that your experience at Big Data e-conference will be worthwhile and productive. Our conferences have a reputation among delegates and suppliers as a must-attend event. I hope that the highly focused business development opportunity through the cutting edge conference program and the numerous networking opportunities will all contribute to a successful and enjoyable event for you. Now, I would like to warmly welcome our speakers for today's conference. I'll introduce them. Our first presenter for today's conference is Mo Hagigi. He works as hybrid cloud build leader at IBM. He will be presenting on cloud native development and multi-cloud strategy. Then we have Clarence Tan, the data analyst from DBS Bank. He will be presenting on getting into a tech career as a non-tech individual. Then we have Matt Adamczak. He's a data scientist at PAF, Game Sport Casino. His thoughts will be on data quality is the key factor number one. Then we have Julie Rosser. She's working as a CEO at Pregenerate. She will be exploring the big data needs and upcoming trend in healthcare. Then we have a networking break for 15 minutes. And then we have with us is Laurent Picard, the developer advocate from Google. His topic will be building smarter solutions with no expertise in machine learning. Then we have John Batsett, working as distinguished architect at Verizon. His topic is big data serving the last frontier processing and interference at scale in real time. Then we have Camillo Emersi, the country head of data management at Absa Bank. He will be covering how does data will grab a chair in the room, ecosystem perspective. That's it for the speaker lineup. I hope that we will learn from each other. Now, our first presenter is Mo Hagigi. He will be with us within few moments, so stay connected. Thank you. Hello, good morning, Mo. How are you?
Can you hear me well?
Yeah, I can hear you. Can you hear me?
Perfect.
So how are you, Mo?
All good, thank you. How are you?
I'm good too. Thank you so much for asking. So, Mo, we welcome you at our conference. Thank you so much for being a part of our conference. And Mo, can you please share your screen?
Absolutely, just a moment.
Okay, sure.
I'll just put it on. Okay. Why doesn't it come up? Share. Okay, now I've got it.
Yeah, I can see your screen now. So, ladies and gentlemen, Mo Hagigi is with us, and he will be presenting now. So, Mo, you can start your presentation now. The stage is all yours.
Thank you very much. So, can you see my presenter view, or can you see the actual view, which is the right one?
Yeah, it's your presenter view.
Okay, so let me change it. Is it okay now?
Yeah, that's great.
Okay.
Okay.
Got some issues with my screen. Just a moment.
Okay.
Is it fixed now, or is it still presenter view?
Yeah, it's again the presenter view.
Let me apologize. Let me just check it again.
Sure, no issues.
No changes, right?
No.
Okay.
Yeah,
okay.
it's good now.
I need to go this way. Perfect.
Okay, so Mo, you can start your presentation. Stage is all yours. Good luck.
Great. Thank you very much. Good morning and good afternoon. Thank you so much for joining my keynote on cloud native development with multi-cloud strategy. Today, I'm going to tell you why cloud native development matters and why multi-cloud strategy plays a very important role in big data and data pipelines. So let me start by focusing on what is actually big data. Big data is all about driving value from data, and by that I mean harvesting business value. We and the object around us are more connected than ever before, and this leads to more and more data sources, resulting in an amount of data that is constantly growing. Data generated from social media apps, web applications, IT sensors, and so on. And as a variety of data sources continues to grow, so does the complexity of driving meaning from the data. And the increased volume of data requires increased computing power in order to drive value from the data. Traditional computing methods simply don't work on the volume of data accumulating today. And most importantly, we have to look at it from data privacy and security perspective. Not all types of data basically can be freely moved to public clouds, and that is why we need to have a strategy in place that we can actually combine multi-clouds together and have this on-prem and public cloud and also private cloud together as one strategy. So let me just focus on the hybrid cloud and multi-cloud. So what is the role of multi-cloud? A multi-cloud enables a company to combine best-of-breed cloud services and functionality from multiple cloud computing vendors. And they can also choose the optimal computing environment for each workload. And that's a very important point when it comes to combining different cloud platforms. And also move workloads freely between public and private clouds as circumstances change. So basically, hybrid cloud and in particular, hybrid multi-cloud helps a company to achieve its technical and business objectives effectively and also cost efficiently than just a public or private cloud on its own. So now let's take a look at DevOps in the context of multi-cloud. And obviously for the big data side, that's actually a very important point. But before we do that, I get often asked about the motivations behind multi-cloud strategy. Therefore, I would like to explain a few concepts first. So let's take a look at the motivations for having multi-cloud applications. In conversations with our clients, depending on whom we are talking to, motivations for multi-cloud are subjective. Cost reduction is always that common reason in a majority of our conversations with business execs. But that one aside, C-level execs are most interested in providing business flexibility to their clients and delight them with new and competitive features. Developers, on the other hand, they want to expedite their journey from development to testing to staging and production, and whatever tools actually can ease that sort of journey, they usually vouch for that. And operation engineers, on the other hand, if you look at them, they're mostly motivated to simplify the operation and increase the security and obviously reduce the cost. But then for the last decade or so, there's been this new team which sits somewhere between developers and operation engineers, known as Devops, and almost replaced developers and operation teams in many firms. For the DevOps teams, portability is #1 factor. And obviously, as I will explain to you later, cloud native development plays a very important point to bring that portability. So let's take a look at the most important factors for DevOps engineers, portability, as we pointed out. But there are different types of portability. We've got application, workload, and functions. And here's a quick example of what is that like to have a hybrid cloud and have a hybrid multi-cloud. So you could basically just move your workload freely between different cloud platforms. It could be your private cloud, or it could be different public clouds. There are many reasons for that. Some cloud providers, again, all the numbers here are estimates and they're not accurate. So this is just for presentation purposes, but it's all about matching the right workload to the right cloud environment for your business. And obviously different cloud providers, they've got different specifications and functionalities that you may decide to go with them because of those features. Some of them, they have a shorter downtime. Some of them offer you a type of computing engine that you might be interested in that based on your workload. And there may be so many other reasons. From IBM's perspective, obviously we are the pioneer of hybrid cloud, and security for us is actually #1. And obviously we've got our sort of expertise, industrial expertise as well. So there might be different reasons why you basically go for a particular public cloud. So now let's just start by asking this question: how can we design an application that can be updated continually without downtime? Different teams can own and evolve services, and our application, our big data application, can be migrated from one cloud to another seamlessly. And there might be another reason behind it as well. So for data sovereignty and privacy perspective, sometimes you've got to put your application on the same platform, cloud platform, that your database is it basically resides. So sometimes that's on a private cloud where you have users' data, and for that reasons, you've got to actually put your application there because you can't really migrate or transfer your data from your platform. And that's why you need to have a multi-cloud strategy in order to build your application once and deploy it anywhere, rather than just building one application for each public cloud platform. So the answer to all the questions that I mentioned is actually cloud native development. Cloud native refers to an application, refers to how an application is built and deployed, rather than where the application resides. It basically defines that the application must be built, delivered and operated in a way that it is not hardwired to any infrastructure. And how does cloud native development make those happen? Simply by relying on microservices. Microservices architecture is the building block and most essential ingredient of cloud native applications. A cloud native application consists of discrete, reusable components known as microservices that are designed to integrate into any cloud environment. Here's a quick example. As you can see on the left-hand side, we've got this monolithic application, which is the traditional or conventional way of developing an application. And obviously all the functionalities and the modules are bundled up together. And the problem with this model is that obviously if any part of the application fails, then your entire system becomes unresponsive. And especially when it comes to big data and AI applications running on big data, that could actually become quite problematic, that your database also sometimes gets affected because you won't be able to pull data from your database into your application. Whereas on the right-hand side and on the left-hand side, obviously, we've got the monolithic applications. On the right-hand side, we've got the microservices. Microservices architecture advocates partitioning large monolithic applications into smaller independent services that can communicate with each other by using HTTP and messages. And in that case, obviously, we partition different parts of the application based on their functionality, business functionality and capabilities. And that gives us a system of services that each service is actually highly maintainable and testable. The services are loosely coupled. So for instance, if the inventory service goes down, it doesn't mean that your billing service is going to become dysfunctional. So that's actually quite interesting from the from that perspective, to keep your applications up and running. And obviously updating your applications also become quite important, as I will get to that in the next slide. So if you look at this monolithic applications, again, the old way of building applications, you've got all your services in one place, your data visualizations, your user interface, your data parsers, and your analytics are all together as one application. What we do with microservices, obviously, we break them down into multiple pieces. They're all independent with their own libraries as containers, as I will get to that shortly. And that basically gives us the choice also to have the platform and the language and different aspects, different tools to basically develop them. And you can actually assign different teams to different parts of your applications without depending on each other. And if I want to wrap it up, I can basically look at it this way. Services with microservices architecture, services can evolve on different timelines. You don't have to rely on each other. And obviously services can be deployed separately, so you can update them and deploy them separately without making your entire applications unresponsive or waiting for different parts of the application to be updated at the same time. And also you can choose your technology, as I pointed out, your technology stack according to what best fits the purpose. And also it helps you, it gives you the ability to scale your individual services dynamically. So for instance, if you want to just scale your analytic engine, you can just scale that part. You don't have to scale your entire application, because if you do that, then obviously that becomes a very costly operation. But the most important factor is, if a single microservice fails, the overall application remains functional. And that's basically the next part, which is containerization. Once you actually partition your application, then you can container each one of them with their dependencies and libraries, and that basically makes them independently deployable, so you can actually put them on different cloud platforms. But I will get to that shortly. So the key drivers for microservices is application performance, flexibility and speed, and obviously adoption is quite widespread because of that. So if you look at the number of companies moving towards cloud native and microservices, is huge. 53% of applications are going to be cloud native. And also from the flexibility and speed, as I said to you, given that the teams can own different parts of the applications, they can evolve each part separately. And again, from the big data perspective, you always have this massive separation of your applications, your database, and your analyticals. But also you can look at it from the teamwork and culture perspective. The small teams can own specific components of the overall applications. There's going to be an enhanced collaboration between the application developers and IT operations experts, who basically, at the moment, this doesn't exist. And also you can continuously and centrally integrate source code updates across the team. That was actually quite important during the pandemic, because for big applications, companies started crowdsourcing and outsourcing different parts of the applications to different teams across the world without having any sort of dependency on each other, and they could just work on it and evolve them and deploy them. But then here's the question: how are we going to orchestrate our microservices? Let's say we've got a big application and it's got many parts to it. That becomes a little bit of a problem from the orchestration perspective, kind of combining and meshing all these services together. And that's the answer is Kubernetes. Kubernetes is an open source system for automating deployment, scaling, and management of containers applications. So what you get out of Kubernetes, obviously a multi-container applications must run on a multi-host environment in order to eliminate that single point of failure. So if one host goes down, your orchestration platform, Kubernetes, can easily move the workload to another host. And that's a very important one, because obviously we are trying to get rid of that different parts of the application being dependent on each other. But then when it comes to a single host, if the host goes down, then that becomes a problem. Therefore, Kubernetes can easily move the workload automatically across different hosts to basically recover from failures or if anything happens in the system. And then the other one is we need to be able to create new instances of our individual services, as I pointed out. So if you decide if part of your applications one of your microservices needs to be scaled because the demand has gone higher, then obviously Kubernetes can take care of that by scaling that particular microservices rather than the old VM type of when we used to scale VMs, we had to actually throw resources at a VM, at a virtual machine for the entire system. But whereas with Kubernetes, we only scale the parts that they need a scalability and high demand. The other one is about scheduling. When you basically one or more of our services need to be updated, or let's say we are adding a new service to our mix, the orchestration platform must be able to automatically schedule new deployment and create new instances of our container with zero downtime. Another one, Kubernetes scales and manages our containers according to available underlying resources. That's again another important point. So it's not just about multi-hosting, but also having this ability to manage the resources, the underlying resources, and that's what Kubernetes basically takes care of. Last but not least, Kubernetes checks our containers continually to make sure they are healthy, and in case of any failure, it will take action to reinstate our deployment or create instances or restore the services. So Kubernetes, with Kubernetes, we state what we desire about our application, such as the number of instances of our individual services and the allocated resources. And then Kubernetes observes the actual state of application and will keep on adjusting and readjusting our resources to make that happen. So it is always this continuous reconciliation of observed and desired state. So that's what basically Kubernetes does. It always looks at what our desired state is, and it will try to make that happen. So let's go back to our deployment scenario on a high level. So we basically broke down our application into containers, and then what would happen next is about the deployment is basically Kubernetes creating new instances, spin up a pod with Docker container in there, and that's basically new instances of our microservices. And then based on the load, each one basically gets replicated. And that's again depending on the load and the sort of demand, and then basically we scale our application accordingly this way, and then obviously now we need to create these sort of services between our microservices to be able to communicate with each other, and obviously expose our applications to the outside world or to the internet, basically to make it accessible to everyone. And that's basically where Kubernetes cluster, as you can see in that blue box, that's basically what Kubernetes is going to do with our microservices. So if you want to do that with, today, that's going to take you a very, it's a lengthy process with a number of steps. So you've got to build your Docker image, and that takes a little bit of time. And then, your Docker file also needs to have all the details of your containers. And then once it gets to the Kubernetes side, you need to start running commands one after another, and obviously that takes a long time because every time you make you make some updates or add new services, you've got to go through these steps on and on. And again, sometimes you have to use a YAML file because you want to run a batch operation. And basically, it's about 12 steps, as I put it here. It's about 12 steps that you need to do with Kubernetes. And when you look at it under the hood, what basically happens is you've got your kubectl or kube control sort of command line. From a command line interface, you communicate with the master node, and the master node basically goes ahead and make that happen in our worker nodes. And then all the operations that I described in the previous slide, it all happens here. But obviously, as you can see, this is what's inside the Kubernetes cluster with different components. Now, let's take a look at what we can actually do to get rid of this sort of complexity when it comes to these sort of operations, and that's basically Openshift. Learning Kubernetes commands, having to containerize microservices, and working from a command line interface, obviously they are not ideal for developers, especially and data scientists who want to focus on coding and enhancing their applications. And again, for data scientists in particular, Kubernetes is not a very smooth sort of operation and journey, and that basically makes it quite complex for them to deploy an application. And that's basically where Red Hat OpenShift can actually help us, because Red Hat OpenShift is built on top of Kubernetes. It brings along all the brilliant features of Kubernetes, but it bundles Kubernetes with some essential features that that ultimately basically provide the best experience to both developers and operation engineers and data scientists on the other hand, because they can just deploy an application, whether it's a Python application or a Java or you name it, they can just do it with one click, literally from one click in their cluster. So basically, how does it achieve that? Is through a number of automated workflows which are not available in Kubernetes, and that's basically how OpenShift does that. Those automated workflows are the results of components that are drawn here in this diagram. Kubernetes is wrapped around an enterprise-grade Linux operating system, networking, monitoring, registry, and more importantly, authentication and authorization service. So that basically brings us to the top important features of OpenShift over Kubernetes, and why basically it can actually help us with microservices deployment. So that's automation, agility, and security. But as a developer, you want to get started on coding. As a data scientist, you want to start coding as quickly as possible rather than spending time learning about different platforms, tools, and services. And that's what basically OpenShift offers. OpenShift comes with pre-created quick start applications to help you build your application quickly. So there are some Python files, some Java files, Node files, you name it. You can easily just go in there and write your hello world and you're up and running and you can deploy it immediately. That's a very important point. And again, it's got different databases as well. If you've got a Mongo, SQL, anything you can imagine, you've got it there as a template. So you can just basically click on it and connect the components together. And then as a developer, you want to focus on coding and not worrying about what's going to happen in the background. So you want to commit and push. Most data scientists these days, when they write a Python application, they want to just focus, commit and push from their Git. And that's basically what OpenShift offers you. You basically just push your updates, and I will show it to you in the next slide. And then on the other hand, if you don't want to use your public cloud services, OpenShift comes with code-ready containers, which is the local version of OpenShift on your own machine. And that gives you full advantages of OpenShift on your local machine. So you don't even have to rely on a public cloud. So from the, that sort of commit and push that I mentioned, so here's an overview of that one-click notion. So OpenShift basically takes care of all the building and deploying your application. Developers can focus on coding, and the rest of the process, such as building an image and deploying an image, is all taken care of by OpenShift source to image, or S2I. So you don't have to containerize your images, you containerize your applications or microservices as soon as you make updates. It's all going to happen automatically. So all you do as a developer, as a data scientist, is just committing your code, your new updates to your Git, and everything else is basically taken care of by OpenShift. So from the developer's perspective, that's another important part. It's about, the sort of environment you're working, and also about the sort of public clouds that, if you want to move your application from one place to another. Let me go through that very quickly. So one of the most distinctive features of OpenShift is this amazing web console that you can see on the right-hand side. It allows you to implement almost all tasks from a simple graphical interface in your browser. You can build, deploy, expose, update, and almost implement any task from two different perspectives of developers and administrator. And again, for a data scientist, all they need to do is just clicking on one of those basically buttons and say, here's my application, deploy it for me, and they get a URL and their application is deployed. Whereas with Kubernetes, as you can see on the left-hand side, you've got to run everything from a command line interface. The other important point, going back to my first and second slide, is about that multi-cloud environment. With Kubernetes, you get different flavors from different cloud providers. And obviously, when you want to move your application from one Kubernetes service to another, you need to make a lot of changes based on the plugins and all the connections you've got in that system. So it's very vendor specific. Whereas with OpenShift, it's exactly the same experience. So OpenShift on AWS, on Azure, IBM Cloud, GCP is exactly the same experience. So that gives you a lot of flexibility to build it once and deploy it anywhere. And another important point, the last one, is all about Kubernetes OpenShift support, the enterprise support that you get from OpenShift, and those quarterly releases and the security patches and features that come with it. So OpenShift is a production grade open source product, whereas Kubernetes is a production grade open source project. Those are the differences. And if I want to give you one last highlight, is basically comparing Kubernetes to OpenShift. It's like comparing an engine to a car. With an engine, you can't do much. You can't go from A to B. Whereas with OpenShift, you've got everything ready and you can just get in and drive. And that's basically how I sum up this part. And then the last but not least is actually about the operators. Operators are small programs into your cluster that monitor your application continuously, and then they make sure that you're running according to instructions. And this is a very important part for the big data operations, because you need to have your analytical parts to run as an operator on your microservices, and this helps you a lot. And also through the operator hub, you can find a catalog of applications from different vendors. And also it helps you to package your solution and put it on the operator hub for anyone out there with an OpenShift cluster to install your application with one click, literally one click. And obviously the rest of that is about the pipeline and how you can actually from the continuous integration and delivery. OpenShift has this integrated feature with Tekton that everything you do basically gets automatically integrated and added to your applications. Again, I don't want to go into details because of the time, but the last part is about multi-tenancy. I think this is a very important part for the big data projects, this is the theme of this conference. And multi-tenancy is another important part, because that's a mode of operation where multiple independent instances of one or multiple applications operate in a shared environment. And with an OpenShift cluster, you could have your different applications running in parallel, but again in complete silos, and that gives you full control over your workload, security, network policies, resource quotas. And also sometimes you could have your development team running in one project, your production team in another, and you could have your staging or testing somewhere in the middle. So you can take full advantage of your cluster by partitioning your non-production environment from your production. So this is a very important point. And again, I don't want to go into the code-ready workspaces. These are not that important, but again, those are tools that you can actually allow your team members from different parts of the world to contribute to an application remotely from a simple web browser, rather than just installing the entire thing from the beginning. So that's also very important. Again, I don't want to go into what we do, but if you're interested to learn about OpenShift, Kubernetes, microservices, please take a look at OpenShift World Tour. Here I've got about 8 hours of video showing you all the steps you need to create your applications. Actually, for this one, I had created a COVID-19 application for analyzing data, COVID-19 data from different parts of the world. So in this series, I show you how to build your applications, pull data from different data sources, and then deploy that as a Kubernetes applications, as an OpenShift application, all the way from introduction on microservices and why you need to do that. So I think you will find this quite useful. It's on developer.ibm.com/OpenShift-World-Tour. With that, I would like to thank you for attending my keynote. Hope you have enjoyed it.
Thank you so much, Mo, for your perceptive presentation and for participating so effectively. You have touched so many critical areas which are solid need of the hour. And thank you so much for being a part of our conference. We are looking forward to work with you in our next conferences. Thank you.
Thank you very much.
Okay, so ladies and gentlemen, our next presenter for today's conference is Clarence Tan, and he's with us. And he's a data analyst from DBS Bank. And Clarence, how are you?
Hi, I'm good. How about you?
I'm good too. Thank you so much for asking. Actually, Clarence, you can start your presentation now, and thank you so much for being a part of our conference.
Okay, all
Uh,
right.
can you please share your screen?
Sure. Let me try. Yeah, are you able to see? Yeah.
Yes, I can see your screen perfectly. Okay, so Clarence, you can start your presentation. Stage is all yours. Good luck.
Okay, all right. Thank you very much. So actually for today, I know there are a lot of experts out there. So I for myself, I prefer to talk a little bit more about my journey and how I actually enter into this industry. So my audience is kind of more related to the non-techie folks, which are coming from maybe business background or other kind of backgrounds, and how to eventually come to this industry, right? So a little bit about myself. I used to come from accounting background, or rather a non-technical background, and somehow I'm able to make my way into the area of data analytics, as well as being on the same standing as those developers, as well as experienced data analyst. So I'm kind of like sharing my journey, how I'm actually get there, and probably it's more of a mindset kind of thing. So it's not so much of a technical thing that I'll be sharing. Uh, One problem I had, because like I'm also an instructor in a coding school as well. So I do teach quite a number of topics. So it's also quite an issue for me of like, how am I going to find a topic that's interesting to bring to this seminar. Yeah, and usually my audience are quite intrigued about my journey, so I thought maybe this is a good chance for me to share more about it, right? So first of all, I want to introduce myself. Hi everyone, everyone in this conference. So my name is Clarence Tan. I'm a data analyst in DBS Bank. So DBS is a local bank it's one of the biggest local bank in Singapore. Right, so my role over there currently is more towards the ETL process. If you all know what's ETL, is the extract, transform, and load. So it's more of a data migration kind of a project. Uh, Prior to that, I was in other financial institution, also doing data work and doing more of a data analytics end-to-end kind of life cycle. So the typical things you hear is like data mining, finding insights. My role consists more on the customer analytics side of it previously. So it's dealing more with credit cards and finding insights to kind of like do cross-selling for your products, as well as to boost revenue for the other financial products. So I graduated from SMU. So I went back to kind of like take another master degree to kind of like upskill myself in the analytics track. Because somehow I was very passionate about the area of analytics, right? And I want to share more of it, how I got all this inspiration, right? Oh, okay. So right now I'm a data analyst, and as well I'm a data instructor for General Assembly. I suppose you might know where is General Assembly. So I'm like a boot camp instructor teaching like SQL, Advanced Excel, as well as Tableau. And I also I'm an instructor for other coding schools, teaching as young as like secondary school kids, right? Nowadays, they are actually picking up Python as well. So it's pretty amazing that how everyone is trying to get into this industry, right? So this is, I've been an instructor for quite a few schools. And in my personal journey, I do like to go for boot camp as well. I'm not just a educator, I'm also like a learner also. So even though I was specialized in data analytics, I also went for boot camps in the area of like software engineering, data science, kind of to like upskill myself in those areas as well. But I think more importantly, I think it's because what is interesting, because I come from a background of accounting and finance. So previously, my background is totally non-technical related, right? So when I first see code, I feel like it's blurring my vision. It's kind of scary to me back then, right? But somehow I got a liking for it when I was in the working industry, and I realized that it kind of propelled my career to a different path altogether, which I'll share a little bit more also. Yeah, and personally, I do like outdoor activities, scuba diving and everything. Yeah, and because of my journey, I also pick up like mentoring. I've been going for a lot of mentoring programs, and I do coaching on the side to help people to get into to the area of tech. Okay, so let's talk a little bit about my journey, even though I'm sharing quite a lot about it. So previously, I was also working for IBM, and that's where I discovered data analytics. So if you all have heard of the technology of Watson Analytics, so that was the first analytics program that gave me a very good impression about data analytics. The visualization of it and um, the technology behind it, I think it impressed me so much, right? That I feel that it's a journey that I want to take up for my future, as well as going forward. Whichever career that I want to take is very related to the technical area. All right. So a lot of people come to me being concerned about, how is it like when you jump over to the next stage, right? So there's actually a lot of research done behind when I was taking this, before I took this leap of faith. So it's like researching like what's the returns, right? So every time when we want to do something of a huge change, we want to think of the returns behind it. So there's a lot of research behind it. And eventually, I think is to take the leap of faith to get into this technical area, right? So quite a lot of my friends will come to me over coffee session and they will ask like, when or how, will you take this leap of faith into the area of tech? Okay. Just to share that this seminar is, I mean, my presentation is not so technical, but it's kind of like putting more of a mindset kind of a presentation, especially for the non-tech folks out there. Personally, my skill set is more onto the SQL as well as Python, which I do teach in normal boot camps to upskill beginners, right? For myself, I took masters as well as bootcamp and as well as a lot of online courses. So yesterday, I just went to check my LinkedIn Learning. I realized that I've completed about 700 online courses. All right, so that's kind of like the drive that I have to pursue this kind of career. Right, then towards the end of my yeah, 700 is crazy. Yeah, man. So if you were to stalk my LinkedIn, I think I never provide here, but you will realize that every month or every week I may be posting a certificate online, right? Because like that's the drive that I have to learn something new. So in terms of the kind of exposure that I get, I started off learning data kind of related stuff. And then now I'm moving on to the data engineering side of it, learning more about databases. And then I expand my knowledge into the data science and machine learning. So this is kind of the drive that I have to keep pursuing growth for my learning, right? So this is something that I would really want to inspire a lot of people. And 700 is as of counting now. I maybe in a few months time, I might be able to reach 1,000 courses. So I'm hoping to reach there, right? And all this kind of learning, it should be kind of purposefully, right? Meaning like when you're learning it, you're really learning it for a reason. And the whole idea is to encompass the whole ecosystem and learning it from a very deliberate kind of a perspective, right? So the whole idea of me is because like I really want to uh, be able to understand the whole end-to-end process, right? So even I talk to developers, I know what they're talking about. I talk to business people, I know what they're talking about. Even I talk to the IT people, I also know what they're talking about. So I can form a kind of a common bridge across different kind of departments and as well as other folks, right? So after my master's, I also was being offered a few data analyst role. So my first start off was in the credit risk area, where I'm doing more of a credit risk kind of a modeling towards the data analytics. Fun fact is probably to share is probably like trying to determine which group of people are likely to default on their payment. So you kind of like study the attributes, you study their purchasing pattern, the how often they pay back. Yeah, so these are kind of things that we do study to give a better insights for our business managers. And of course, I'm very enthusiastic about data. So I'm not only learning all about it, but I also want to share with many folks out there as well. Okay, so planning a roadmap This is one of the agenda that I want to give. So it's the things that I've also share with my peers and my friends. Quite a lot of time people are stuck at, they'll be stuck at, okay, I don't know where to go from this on, I don't know how is it like, what's the scope like and everything, what if I don't like at the end? That's the common question that I normally receive. So quite a lot of research is about what do you really like about your career goal? Technology is quite a spectrum, right? So even if you're in the data area, there's data scientist, data analyst, data engineer, solution architect. There's a range of data roles. If you're not keen on being the uh, doing the dirty work of the technical part of it, probably you can look forward to become a project manager where you're still handling IT projects, right? And you're still within the industry, but you're not so involved with the technical side of things. So it's pretty important to research what kind of role that you are like. It's pretty tiring if you were to go to work one day and you feel the kind of a sucky feeling of not being able to start work and everything, right? So it's pretty important to know if when you are doing the work, do you really like it? Do you really like writing SQL scripts every day? Are you liking it when you're writing a Python script every day, right? And there's a lot of iteration, a lot of debugging. Are you comfortable in doing all this kind of work? Yeah, this is something that you kind of have to ask yourself when you're moving into this industry, right? So do you like data development and project management? Okay, so lastly is about figuring out how to get there, right? So the three common ways is masters, bootcamp, and self-learn. I did all three. That's how hungry I am, right? So I think masters is kind of like the fastest way to get accreditation, as well is kind of the best way to get the HR attention. So sharing a little bit of the job hunt or how I was being recruited for different companies. Normally, I think having a master's, it kind of picks you out better from the system. I think like nowadays things are being automated. Having that name in the resume kind of pick up the system better, but it's not the main thing for you to getting the job. Quite a lot of it is also mainly on your experience, whatever projects you have done before, right? For bootcamp wise, I think it's one of the second fastest way, and it's very practical in terms of like you're always coding the whole day from 9 to 6. You're just coding. It's very, very practical. You're just hands-on coding from just every day, and you have kind of a capstone project where you can get to present to probably your future employers. I think it's a very intensive, right? Because it's like probably within 40 days, you got to kind of come up with a product. Whereas like in the corporate setting, probably coming out with a product might take months, right? So within this 40 days, you're kind of like putting in a lot of learning into this period. Okay, lastly, the self-learn. I think self-learn is pretty important. Wherever you have uh, gone to a new career and everything, I think like self-learning is a part where it keeps you growing, right? And I, for myself, I feel that I always pursue a lot of self-growth. That's where you can go beyond on where you're at right now, right? So I've learned more than just like data analytics, right? Because I'm like expanding more into this data career. Okay, there are also some ways also that I suggested to my mentees as well as to my peers. Also, there's networking opportunities or volunteering opportunities, which you can find as well. So I'm also a data curriculum lead for like a non-profit organization, which try to help beginners to come in to learn how to code beginner style, learning how to find some projects, to boost their profile. So these are some ways they can go about as well. Networking definitely help, trying to find projects to build up your portfolio, right? And also like trying to understand what the job entails. If you looking for a mentor, especially, all right, it's good to find out what's their day to day and what's the skill set required. So for myself, I do like try to focus on the job description and I try to fill in the gap. So before even like looking for a new job, I will try to bridge that gap as close as possible before like going for this job interview. So at least I have some knowledge, right? You won't have 100% of the knowledge going to a job, but at least you're preparing yourself So when you're entering in, you can then absorb the whole 100% of the knowledge. And lastly, I think for myself, I have taken a lot of interviews, especially I transited into this career. Definitely not easy on my end, especially when I come from a non-technical background. So a lot of practice session, all right? And I take every rejection and every failure as a form of learning, right? So the number of rejection failures is kind of a way for me to know where my gap is. So I fail a lot of SQL tests, even though I teach SQL. I fail a lot of SQL tests as well. But I know that this is my gap. And what I do next is I will go back and I try to study how am I going to code this in the future. So sorry. So these are some things that I try to help myself, right? Because I believe in like failing forward, just keep going forward, right? So even you fail, but you're growing and you're still moving forward, right? So imposter syndrome is something that my friends are usually very scared, especially when they have no computer science background, no technical knowledge, and definitely they always ask me, oh, I have the lack of experience. So one of the sharing that I want to share that I have a chat with a mentee recently, and she was like being asked to go to like a machine learning engineering team, right? So she felt that she might not feel good enough to get into this team, or rather she feel that she'll feel very inferior if she go into this team of very awesome people, right? Very technically strong and they know their stuff, very experienced. So my advice to her was, if I were you, I definitely want to go. Reason being, right, I want to surround myself with great people. Okay, I'm a bit, maybe my mindset is a little bit different. I do think of, I want to learn more from them. So the smarter you are, the closer I want to get to you. I want to know how you think, how's your logical mind, I mean your thought process. How do you think about solving different situations? Because personally, I'm kind of a new career as well, right? So if I want to go in, I want to know how you deal with certain situations, and I want to get in with you, and I want to be on the same mindset as you, right? So I'm growing, kind of to like catch up to you. So rather than feeling scared or this imposter syndrome, for me, I would say I will feel excited to go to this kind of team, right? To learn from everyone. And also one day, because you surround yourself with these great people, you'll be able to elevate yourself to be as good as them. And also about getting ready for it, always know that you'll never be fully ready or prepared. Some people want to be 100% ready for a certain task or 100% ready to take a certain role. I myself feel that you will never be ready. I can practice hundreds and thousands of SQL coding, but when I go to take the exam, if they throw me a whole new unique question, right, it's still going to throw me off a little bit also. So, so you'll never be 100% prepared, but you should get yourself kind of ready to go in and take the challenge, right? See it as a form of challenge rather than you must get that 100% kind of a score, right? And this kind of challenge will push you to grow, and it's a form of progress as well, right? So if you feel it difficult, that means there's something for you to grow. If it's too easy, then I think, yeah, you start to be a bit complacent and relaxed and everything, right? So if there's something that is more challenging, I would say, just go for it, right? Because when you're able to overcome it, actually, you have grown to another level altogether. And also, there's this part of the analysis paralysis. Most of the time, we think too much, and the more we think, all right, the more we stay in the same spot. So for me, I feel that it's better to take a decision rather than wait on the fence. So if you're thinking about going for the boot camp, right, you research the benefit, the pros and the cons, right, and then it's time to take a decision. I don't think that we should keep waiting at one spot and still trying to figure out whether is it to go or not, right? So it's always better to take a decision rather than just wait on the fence for it. Okay, so I want to talk a little bit about the pros and cons, and this is quite related to my experience along the way. So because of the passion that I have for this industry, I realized that the career progression kind of coincides with it as well. So as I feel driven to take more tasks, I feel driven to take more assignments, I realize my career grows along with it. Uh, Career growth also do mean compensation. They do mean better responsibility. Also do mean a different kind of scope for you to handle as well. So I realized that this kind of this kind of thing being coincide together as well. The more you like the topic, somehow the assignments will just come to you. And I think in the long run, it's kind of a very good career progression, at least. And from what I feel like in the data space, especially in the area of Singapore, we do lack the tech talent down here. And I think it's like a great opportunity, if you guys are interested in coming to Singapore for some tech career as well. Over here, we do need people to grow because we are seeing ourselves as like a new tech hub in the Southeast Asia, right? So there's a lot of opportunities down here, and this also signify good growth as well as a good opportunity for career as well. So for those people who are like moving into tech, I tell them that this is like kind of like the best time because we do need people to build up the tech capabilities of Singapore. So like myself in DBS Bank, they're trying to move towards a digital bank. And yeah, there are a lot of projects going on which they need a lot of people to build up this system, right? So it's definitely like one of the career to be in, right? Especially in this time of COVID and the pandemic, the growth of this job is still growing. Yeah, the growth of this job is still up there, and I feel that everyone should try to get into this opportunity, right? To build your profile, right? In the long run, I see that being in tech, data, and in the IT sector, especially in the area of Singapore, being like the headquarters for most company in the Southeast Asia region, there's a lot of opportunities down here, right? Uh, the next pros that I can talk about is, for me, I think it's more of a challenge and learnings. I feel that because I used to be in the accounting role, so it's kind of a very regimental and it's also very cyclical kind of a role. So I don't feel the challenge as much as when I take on the tech. I feel like in tech, there's always a lot of room for creativity. It's not just being technical. You also have to be creative in how you want to do your work as well. So in my day-to-day, I also come up with automation scripts. I also try to figure ways to improve efficiency. So there's a lot of space for creativity, right? Because you know how to code, you also know how to uh, use tech to your advantage, right? And I feel like it future-proof my career, at least I feel, and I hope it future-proofs everyone's career as well, because I feel there's a lot of demand, and I don't see it stopping. Personally, I don't see it stopping. Uh, I do get still quite a lot of recruiter calls regarding about the job availability in the market. So there's still a lot of demand for people with tech skill. Okay, so what are the cons? Sharing about my journey and also for many people out there who are not so technical is quite a difficult journey, especially when you come from a non-technical background. I have friends who come from arts background and they try to come into a technical career. So it's actually quite difficult, especially in the area of coding. I spent 4 years learning about accounting standards. So you're asking me to move into the tech side, and suddenly I need to code and I need to be on par with my peers in my company. It really does take a while to get there. So the amount of courses I take, the amount of practice. When I first started, I think in probably 2016. Yeah, I started around 2016. So I make it a point that every day I will spend 1 hour coding. Can be any language, but every day just 1 hour coding, right? Can be SQL, Python, JavaScript, Java. I practically touch almost every single language, but the proficiency wise is mostly for data side of it is normally the SQL as well as Python, and also a little bit of R as well. This is kind of like my determination to kind of like to catch up with my peers. Because most of my friends they already have like coding background for maybe a couple of years, right? So for me, it's kind of like a catching up game to reach to their level. Also, I have to face a lot of rejections in the beginning as well, because partially they are always looking for people with experience, and me coming in to the industry fresh and new, there's a lot of rejection from many companies, right? So the starting journey is definitely not easy. So to put it into numbers perspective, probably if you send out probably 100 resumes, okay, probably half will come back to you, and out of the half, probably another half of it is a rejection, and out of the half, they'll probably put you to the first round, and probably out of the first round and a half, you probably get into the second round. So by the time you get to your final round and getting to your offer, it probably be 2 out of the 100, right? So that's kind of the competition, and as well as even though there's a lot of job opportunities out there, but the competition is also equally tough as well. So there's a lot of rejection, especially when you first start out going into this industry. All right, so I think this is kind of like my last slide, and also I mean just a sharing for everyone is kind of like to find more important is to find joy in your journey, right? So if you're intending to pursue the tech career, or regardless any other careers, like especially for a career switch, I think it's quite important to find joy in the process. If you're hating it, then something somewhere has gone wrong, right? So when you're moving towards a new career, I think like when you're learning new stuff, I think you should try to find the joy in it, right? If you're feeling good, about learning a Python, a new function or something, right? It's something that you feel good when you upskill yourself. I think that's quite a good sign. At least this is how I kind of felt when I'm doing my my upskilling as well as my own self-development, right? So I think it's finding joy in your journey, and don't be too impatient about it, right? It took me a couple of years to actually to be able to feel the effect of the growth, as well as to feel the opportunities coming to you. So a bit of a patience, a bit of determination, it helps in the process as well, right? So this is just my humble presentation for you guys. I hope you all enjoy this presentation. Right, thank you very much. Yeah, I think there's still time, but I don't know whether for any questions or anything. Yeah.
Okay, so thank you so much, Clarence, for your presentation, and for participating so effectively, and for sharing your experience with us. So Clarence, if someone will be having any question, they will be asking you in the QA session. And thank you so much for being a part of our conference, and we are looking forward to work with you in our next conferences. Thank you so much. Stay
Okay,
safe.
thank you. All right, thank you.
Thank you. Hello, Matt. How are you? So,
Sorry. Yes. Can you hear me now?
yeah, I can hear you now. How are you?
I'm great. I'm at the vacation cottage,
Okay.
so I hope my band will help. Is it okay? The
Yeah,
sound?
it's perfectly all right.
Good.
Okay.
Yeah.
Okay, so ladies and gentlemen, here Mats Adamczak is with us, and he's working as a data scientist at PAF Game Sport Casino. So let's welcome Mats, and Mats, you can start your presentation now. And can you please share your screen? Can you see the green button at the bottom?
Yeah. And now it will be interesting if I take. Will it show? Do you see my screen now?
Yeah.
The whole?
Yeah, I can see it.
Okay, good.
Okay, so Matt, thank you so much for being here, and we are looking forward to have a great session from you. So good luck. You can start your presentation. Stage is all yours.
Thank you very much. It's really nice to participate in this session. And my presentation will be about great data quality and also content-wise, word of mouth. Because I'm working at a company called Puff, and we are a bit different from the rest of the gambling industry because all our profits go to good causes. And we are not trying to find the high rollers. We want to find players who can enjoy playing and without having problems in the future. So that is sort of the background in the company I'm working, and we are in at least 7 different countries around in Europe. And this is the journey we have taken. My background is that I started maybe 20 years ago with business analytics as a consult and making databases. And then after a while, I started also to sell system. And then until 5 years ago, I was working hands-on with marketing. So it's really a new combination, or maybe unique combination, to both know how to do the marketing and also how to prove that it's working or not. So this is my combination. I'm not a programmer in Python or something like that, but instead I understand what is needed to get the numbers. And one thing I think is very important when you are an analytic guy is the difference between knowledge versus wisdom. And it was a British journalist who said that knowledge is knowing that a tomato is a fruit. Wisdom is knowing not to put it in a fruit salad. The guy's name was Miles Kington. And I think it's very common in many companies that people are reading the numbers and don't really put effort to analyze what they're actually meaning. And to start understand, I was working with marketing and I had a problem with my marketing officer that he didn't understand, because marketing could be really tricky to prove if it's working or not. So I started in a technical advice. So that's my first thing I will show you, and then I will show the content wise. So the customer journey, I started to put different conversion points that I could track. So for example, in Google, suspect is a person who can use Google. So very, very high level. And then target group in our case is everybody that are potential customers. And in our case, you have to be over 18 years old. And then how many of these are using gambling in their search result? And how many are clicking through to our website, or in some other cases coming to a partner landing page and then click through. So that is the way we have done all the different channels. For example, paid search or paid social or display. It's a sort of the same thinking. And when they are coming to the web page, then I have decided that prospect if they are visiting the web page. And that was the level we had 5 years ago, knowledge what channel did they came from when they visit the web page. And that of course is not good enough if you really want to know what kind of customer is coming, if they are interested for real or not. And a lead is when they have not bounced, they have do something else on the web page. Marketing qualified lead when they have made the registration, and sales qualified lead when they have accepting the registration. And here we had some big issues with cross device. That means that if they are making the registration on the computer and then they get a ping and then they open the mobile and accept it through the mobile, and then the channel will be email, and that doesn't make any sense if you want to understand. Opportunity, that is when they have made their first deposit, and customer they will become when they play the real game. And nowadays we know the whole way until they come and make the first deposit. That is the conversion point we're doing. I will talk a little bit more about that later. So that is the different conversion funnel. how did we implant it? Because it's not easy in a rather big company, at least in our case, we are about 400 people and different tech departments that maybe not talking to each other so much. But I started a follow-up meeting called Poor to Great, and all the stakeholders participate, CEO, Chief Marketing Officer, and the Chief Technical Officer, and some other hands-on people. And we had 3 head topics, and that has not really changed. And one of the most important are actually page speed and SEO hygiene factor, and then data quality is of course important. And page speed, that is really crucial. And Google had a journey and a survey, and they saw that 50% will abort the journey if it takes more than 3 seconds. And that is, of course, a huge drop if you have paid money that people should come to your web page and they are not even waiting more than 3 seconds. And it's, of course, a bad experience. And I made an investigation in Spain, and I looked how many of the people who have clicked on their Facebook banner actually came to the web page, and that was 10%. And that is a huge drop. And after that, the CEO said, okay, this will put some effort on, and that we have done all since that time. Every month we are looking, and now we have looking on our web page speed and the others. And luckily, Google has started a lighthouse where you can see performance, and the new one is called version 6, and it helps the technicians to improve your web page. And this is how it looked when we did it in Spain. So what we did was made a really fast landing page, and this is with slow 3G. So with the old one, it took almost 11 seconds, and with the new one, less than 3 seconds. And the change was 4,000% more registrations. So it was a huge impact. So how to improve it? Some key points. Eliminate render blocking JavaScript and CSS, because these are the big bad guys. Usually the technicians make a total solution for the whole web page, and on every single page is maybe 3, 4, 5% is only usage, and the rest 95% are only blocking. And that is in our case, or it was, and I guess it's similar in many other companies. And of course, you can optimize images and prioritize visible content, CDN solutions, and lazy loading. So you're giving the feeling that it's happening something. And so there are some tips and tricks. And technical SEO, I think that is really important, because if it takes long time for a web page to load, also Google will rank you lower, and that is of course important for your marketing skills. You can help search engine access through different techniques, and if you have done it logical for a search engine, you have a pretty good chance it's logical even for the end users, the customers. So then we're coming to the most important thing, I think, machine learning web traffic, or the data quality. And you usually say shit in, shit out, but with the machine learning and AI, I would say shit in, shit hit the fan, because if you have something that is wrong, or you have made wrong conclusions, you could get big problems. I will give you an example just. Number 2, cross device. I was told you about that, and that is when you have lost the track of a person when they're coming from the first touch, when they're making registration and then making the acceptance, and even further with their first time deposit. But that is pretty simple to solve if you are taken care of with some kind of identifier. And one really good example that is used in our company is Facebook segment in Spain. Maybe 5 years ago, I was looking at how our ads campaigns went in Spain for betting. And I noticed when I looked at it, the half of the budget was aimed to women 65 plus. It could be great, but of course it was not that. What was happened at that time when they started the machine learning process with Facebook, they had equal segments, and one of them was 65 or year ladies. And they were interested to see on the banner, and when they came to the web page, they bounced away because at that time the conversion point was visit the web page. But I don't know why. I think it was something with the banner that it was a nice looking guy or something like that. So it was interesting to look and see what it was. And the next time they had this banner campaign, it was a little bit more money on this segment. Sorry, the cat is in the background. He will go out. So, yeah, the next time it gets a little bit more money on this segment, and after a while, you had almost a half budget on women 65 plus. So it's really important with machine learning that the person who decides how it works have the understanding. And one other big issue we had was we got a lot of banks as a referral. And that was really strange because we didn't have ban ads on their banks or some special agreement that if they become a customer at a specific bank, you will get the free spins or whatever. So I started to investigate what is really happening. And this is very important, the human behavior. So what I noticed that people who came to our webpage, they put the username and password, and they got the message that the username or password was wrong. And at least in Finland, they can check with their bank if they get the correct username or the password. So they were transferred to the bank, and then the bank sent them back and say, hey, you are not a customer. So they thought they were a customer, but they of course wanted to be a customer. So they create an account, and the last resource was actually the bank. So we had at least 50 people every single day doing this. So a lot of people don't know if they're a customer or not. And we had the opposite also. So key factors for a company that not has a web shop, because it's much easier if you have a web shop to understand the whole flow, is to connect the visitor traffic all the way to the customer data. And how we did it was using Google's identifier and create an external player ID that is not the same as we have in the system, but we could connect them in the back office, and then have some kind of a campaign ID. And if we talk on acquisition, many companies have different formulas. 10% for the first task they're coming to the web page, 20% when they are doing something or something like that. But in our case, we have decided to go 100% when they actually put money in our system. So it's no formula except that and the result. Before we did that and had fixed the cross device and all these kind of issues, a lot of information was in the dark. But now, when we have the full control all the way to customer database, we can really say what is the channel or campaign is working for us. And that has made us get really good customers to a low price comparing to our competitors. Retention, yeah, there I have, instead of using last touch when they are coming and becoming first deposit, we have used first touch. What channel was used when a customer after a while coming back to the web page? So that means if they have been away for 2 weeks, What have they choose? Is it email or is it a Facebook campaign or whatever? So we are 100% in retention. The first touch, what they are using when they're coming back, and last touch when they're used when they're becoming a first depositor. That is the first part of my presentation, and then I go to content. Because PUF have been working and not been able to do marketing in mainland Finland is a long story, but the good part is that we have been taught how to do organic content or word of mouth. So we have 3 different kind of media. Paid media, you pay it and buy it, of course, and own media when you are putting up some information in your channels. And then the best kind of media is, of course, earned media or word of mouth. So that will be what I'm going through the last part before if there are any questions. Word of mouth, in our case, it means it is not only we who should tell the story. With we, I mean the company. Instead, we are giving the user the reason why they should talk about us and the opportunity. And opportunity in this case is that they have channels or technical solutions to do it with share buttons and whatever. So this is the really backbone or the really essence of our strategy to get marketing. Customer behavior in not the technical perspective is, I think it's very important, of course. 8 of 10 purchases starts with a search on internet. That is what Google says, but I think it's pretty true. And if you look how it works, it usually starts with search, and then it's important that you are there and can attract the person who wants to have help with something. Then they want to learn. Maybe they want to fix it by themselves, or they want to learn more what kind of service they need or what product they want to buy. And there you should be there and inspire. And then they are coming to the phase evolute, and there should be and convince. And if you are not on all these 3 stages as a company, it's really important to be at the last one where you can convince. That could be enough. And then the customer buy, and then they will get some kind of experience. And of course, if you have good retention, then they will be ambassadors and they will share. So this is the customer journey for content we are working with. One of the things we did was creating a Club PUF. And Club PUF is this. It started in 2002, and the reason why we started it was to somehow get word of mouth for our customers in Finland, where we could not use traditional marketing. And what we did was we have 50 people will go for a trip around in the world to Las Vegas or South Africa or Bahamas or whatever. And always it is a PUF staff on the trip to help them, and it's not bought some guide or something. It has to be trustworthy so they feel our company. And it's not the high rollers who will win the trip. It's anybody, because the high rollers we are not interested in, and it's a much more big surprise for the people if they win the trip for €1 if they have played. And it's only 25 winners, and they can always bring a friend. And the formula for campaigns are pretty simple. It's before, during, after. And in our case, before was that somebody won a trip to, for example, Las Vegas in February. They have to go to the boss and ask if they can get free 1 week, and the boss asked, why are you needing that? Yeah, I have won a trip to Las Vegas. Oh, how? And then they have to tell the story. And the same thing is with their working colleagues. I'm going to Las Vegas. Oh, nice. And they have to tell the story. And then during the trip, we are also participating and giving them the reason to share in social media their stories. For example, Flickr was very much used of us for photos, and also taking professional picture that they will share and prove that they are on a trip. And then after, they will always remember this trip with 4 stars hotels or 5 stars hotels and tell their friends. So you have the whole flow, and that has been working really, really good. The problem is of course COVID-19, and then we have to stop with this kind of activities. But we have done it for 18 years. And the last part I'm going to talk about is I'm the chairman of Small Entrepreneurs on Åland Islands, and it's a small island with 30,000 inhabitants, and we are very relying on tourism. And I got the mission from our Minister of Entrepreneurs. We have a small own government, and he said, I have to find a new way of getting tourists here, and it should be COVID safe. And okay, then I starting to look around me, what could be COVID safe and what data could give me the solution of this. And I don't know if you have heard about disc golf. Disc golf is like traditional golf, and it's usually it's with a frisbee instead, and you throw 3 times and then you try to get it in the basket. So it's pretty similar as traditional golf. And all around in the world, at least in the North America and in the northern countries, Finland, Norway, Sweden, and Estonia, it was really exploding because you are outdoors and it was really COVID safe. The situation with disc golf is that it's free to play with most of the courses. And that means it's hard to get business. And when it's free to play, then that means that the property where the courses are on is very low valued. So we turn it around and put a lot of courses on this small island, but close to tourist places. For example, restaurants and brewers and stuff like that. And then I looked what is needed, and I saw that it takes pretty long time to create the course, but I got a lot of Åland people gathered, and we created 11 courses in 2 months time. Usually it takes 3 to 5 months before you get one course. And what happened was that we had this 1 year ago now, and we get a lot of attention in disc golf communities, and already today we have a lot of tourists coming now, especially from Finland, and playing. And this I will have a TEDx talk later in this August about. Yes, this was pretty speedy. Usually I used to have some questions during the lecture, but please, if you have any questions about the technical journey we had or the content wise, or please look up disc golf and Åland Disc Golf Island, because it has become a really big influence, and a lot of Americans is coming here next summer. So, any questions?
So thank you so much, Mats, for your presentation and for your time. And I'll ask the audience that if they will be having any question, they can ask you in the QA session. Okay?
Yeah.
Okay, thank you so much for being a part of this conference. We are looking forward to work with you in many more conferences.
Thank you.
Bye. Hi, Julie. How are you?
I'm fine, thanks. How are you?
I'm good too. Thank you so much for asking. Okay, so ladies and gentlemen, here Julie Rosser, who is working as a CEO at Pregenerate. So let's welcome Julie. And Julie, thank you so much for being a part of this conference. And you can start your presentation by sharing your screen.
Thank you.
Thank you.
Okay, let me see if I can share the screen.
Okay.
I mean, I'm sure that I can. It's just always takes me a second.
It's okay. Yeah, I can see your slides now.
Okay, great. Thank
Okay,
you.
so Julie, you can start your presentation. Stage is all yours. Good luck.
Thanks so much. So first of all, I'd just like to thank the organizers for inviting me to present here today. This is a little bit of an unusual venue for me because my background is actually in specialist surgery for horses. So as a clinician and a researcher, I could see how advances in technology held incredible potential for improving patients' lives, not only horses, but also human. And this ultimately inspired me to start Pregenerate, where we aim to combine unique hardware with artificial intelligence to disrupt the way that arthritis is treated. So digitalization, of course, as we all know, has been disrupting every industry, and that includes healthcare. And today I'd like to describe where we are as an industry, what is coming down the healthcare pipeline as far as big data innovation is concerned, and what challenges and bottlenecks we need to address in the near future. In order to understand how big data innovation is changing existing value chains in medicine and pharmaceutical research, we need to understand the different use cases. So we'll look briefly at a few examples of this. And next we'll look at developing trends, which show not only high demand, but also impressive market projections for the next several years to the next several decades. And then I'd like to actually describe to you Pregenerate as a use case in order to flesh out what the needs, limitations, and challenges of developing technology for big data applications are, especially those for startups where a lot of disruptive technologies and use of big data is originating. So let's dive right into how big data is already impacting existing value chains in medicine specifically. Primarily, this is today through synergy with classical methods instead of as a replacement. And that will be true for the coming decades, but maybe not in the far future. So largely the main fields that we see in today's value chain are biomedical research, which is a lot about automated data, but primarily focused on genomics. We also see a lot of change in the existing value chain around pharmaceutical research. So this can be patient stratification and also biomarker discovery. And then, of course, we see actual adaptation of the value chain, which is medical practice. So not only diagnostics, but also predictive indicators as well as telemedicine. So we're going to start with cancer diagnostics because so much is happening in this field right now. It's really no surprise to find big data applications in this space. So we have not only improved diagnostics, but as we're looking at in this specific use case, earlier identification of disease, also clinical decision support, which is significant here. So specifically right now, I'm presenting you with an AI model which has successfully trained to identify breast cancer 4 years before it actually developed, based on mammography. And I like this example because it's simple yet sophisticated. Using an algorithmic approach, the team was able to better categorize patient risk profiles and subsequently apply deep learning to screen early images of patients who later were indeed found to have breast tumors. However, I do want to point out that there are other very different and complementary approaches to big data in oncology and cancer diagnostics, most notably genomic screening, which relies heavily on the relationship between genotype, so how the actual DNA is put together, and phenotype, which is how that DNA is expressed into proteins and molecules and disease. So we tend to assume, particularly in cancer diagnostics that focus on genomics, that mutation of the gene correlates with risk. And in fact, there are many companies that commercialize this today. But we also know that there are probably additional levels of complexity. So to provide a completely different example, again, partly thanks to the sequencing of the human genome, is big data in pharma. So this is an opportunity to take huge amounts of data and look for patterns, trends, and associations, which are not possible with our smaller data sets that we see often in clinical medicine. So this is a more traditional approach to big data innovation that the rest of the industry is more familiar with, because it's hypothesis generating. So this is, instead of a classical hypothesis-driven approach. And therefore, it's less dependent on prior knowledge, which is perfect for pharmaceutical development, right? So because we know that human biology is one of the most complex interconnected systems that we know of, this makes this an excellent target for both machine learning and deep learning, as you can see here in the example provided by Pharma AI, where genomic data can be leveraged on a huge scale to identify ideal targets. And this can then be adapted to the design of next generation therapeutics and also improving clinical trials. And so basically what this looks like is target identification and then lead optimization. And you can even design your preclinical and clinical trials so that you identify the patients that are most likely to be well served by the novel molecule which you're producing. Another aspect of medicine, which is particularly well suited to artificial intelligence and big data, is tackling tedious, mundane tasks, such as image annotation. I think we all know, when we go to the doctor, it's quite common to get an X-ray or an MRI. Here you're looking at a CT scan, and then an MRI is the lower picture on the left. And these are examples primarily of machine learning. For example, Context Flow is an Austrian startup that uses lung CTs to screen for COVID-19. And this is a regulatory approved company. And then there's the Israeli startup Zebra Medical Vision, which has a lot of products. One of them is actually able to identify at-risk patients for osteoporosis much earlier than other technologies, because they use standard routine images, which are taken, chest x-rays, spine, and they can actually detect vertebral compression fractures, which these are not images that are taken to screen specifically for osteoporosis. These are taken for other diagnostic modalities, and they can identify patients with really early onset osteoporosis. And another example here is Image Biopsy Lab, again, an Austrian startup, which can annotate radiographs to save radiologists a lot of time and also to reduce errors. So this is a great example of annotating images for radiology or diagnostic imaging. It is also highly likely that this is going to become a more predictive modality. But I think one of the big points here is that unlike raw genomic or genetic data and pharmaceutical data, using big data or applying big data to the field of diagnostic imaging is still pretty dependent on a need for collaborative networks in order to actually acquire these massive data sets, as well as to extrapolate expertise from the big data industry into applications for medical diagnostics and predictions. This is due to several factors. Primarily that healthcare offers much less open source data. And this is because, one, patients may not want to provide this willingly, and two, it is almost never delivered directly to the provider of the big data application. It is usually through a healthcare provider. So it's an indirect delivery of data, unlike most other industries. And healthcare data is primarily located in hospital or medical charts, which are guarded by law. So that further reduces access. Also, I think radiology is an excellent place to highlight that use of big data is rather complex because this is not like or dislike data, it's really complex data. For example, in radiology, you're going to have variables even down to which instrument acquired the images, let alone individual patient variability. Also, data in medicine is collected intentionally, so it has a relatively high information density compared to most industrial big data. And for this reason and other reasons, the collection can be quite costly. Lastly, individual variation is not independent of the group affiliation. And this is a thread that we're going to continue to see throughout the discussion of big data innovation in medicine. So on that note, individual variation versus population affiliation, in fact, is an excellent segue into future trends. And we've seen a preview of this in the virtual explosion of health apps and digital medicine. So we all know, and we can easily recognize, that the pandemic has been a driving force for emerging technologies in digital health, such as telemedicine and remote patient monitoring. Coordinating projects globally became very important, but COVID also highlighted many unknowns in medicine, like which patients are actually high risk. Is it geriatric patients or is it middle-aged patients who actually suffer the highest mortality rates in the COVID example? Another question which has come to light or come to the forefront: which treatments will be effective for which individuals? Who's going to need a respirator? Who might qualify for vaccination versus not vaccination, for example, in very young children? And perhaps most importantly, how can we improve patient monitoring at scale? So one of the big paradigm shifts in medicine, which has been coming down the bend since before COVID era, is personalized medicine. So everyone is interested in getting rid of this one-size-fits-all approach to medicine. And again, this is primarily facilitated by the sequencing of the human genome. We can now look at personalizing treatment selection based on individual patient factors. So the goal of this being the right treatment to the right patient at the right time. And this comes back to basic approaches, as you can see in the table here, which is cited below. We're looking for personalized risk assessment or diagnosis, which might be performed through genomics. And then this has to be further personalized and brought into the clinical reality by addressing individual patient factors. So this might be imaging results, this might be lifestyle, what's the person's weight, what's the person's mobility, what's the person's age, and also another clinical consideration that is always important is what symptoms are occurring to this patient that we need to treat directly. By collating all of this information in an algorithm and, for example, clinical decision support system, we can customize treatment plans, and thereby we can improve outcomes for our patients. And this leads us into the idea of precision medicine or patient stratification, which are not entirely synonymous, but are very congruent to one another. Because we can funnel both big data and also individualized patient data or personalized data into subgroups for specifically patient stratification. And here we're grouping patients already largely based on their phenotype. So you can group them based on their genotype, or you can group them based on their demographic, their symptoms, with genotype as a second consideration. No one really knows yet which is the better approach. It's thought that the phenotype, which has genotypic consideration in the background, is probably more accurate. Because again, the clinical data is so important and accounts for environmental and individual patient factors like lifestyle. So in this example, we can actually enrich clinical trials. Let's use oncology by identifying patients who are the most likely to respond to a specific chemotherapeutic agent based on what their gene expression is in their blood system. One of the companies who's doing this, I wanted to say here, is Foundation Medicine. Have a look at them. Their pipeline is really interesting. There are some concerns here though, because when we're looking at subgrouping patients, we have to consider who is represented. Now, a really good way to illustrate this example is in hospitalization, quite commonly, women are administered less pain medication than men. And this translates into how their medical records are coded. Much like differences in, for example, again, gender symptoms in congestive heart disease. Women have different symptoms than men, which is to say that the data generated and collected reflects social realities, including other factors like access to high quality nutrition and private healthcare. So the reason that phenotypic data is probably more interesting is because it adds layers of complexity, which reflects our actual life. So while we know that personalized medicine will bring a shift from the standard patient, data must be collected and interpreted carefully. So specifically, this has to be well coordinated. Who are we assessing? What structures are already in place that we might not see? What additional interests are at play that maybe are not obvious? Who's participating? We have to enable patients across an entire section of population access to clinical trials so that we can improve our patient stratification utilizing big data approaches. And also an important point, particularly for healthcare providers at this level in patient stratification, is the evaluation. Who's deciding about proper outcomes? What are the criteria? Who's administering the treatment decisions? And primarily, what is done to reduce biases? So one interesting opportunity to equalize some of this data collection is via remote data collection, which can be facilitated through monitoring and of course also telemedicine. This field we all know has been tremendously advanced by smartphone applications, but it offers virtually endless possibilities, including digital twins, which is really trendy right now. For example, Cypher skin, which you see here depicted, has a hardware which is impregnated into compressive sleeves, and it continuously collects motion data, patient movement data. And this can be assimilated into 3D visualization or reconstruction, which can actually be leveraged not only for physical rehabilitation or monitoring of patient recovery, patient outcome, can also be used for enhancing sports performance and training. One of the ways in which it is just now beginning to be applied is for monitoring disease progression. So one example of this would be acceleration of tremors in patients with Parkinson's disease. So what I'd like to do now is actually present what we're doing at Progenerate so that you can see from the ground up or from the bottom up what the needs we have for AI and also what our limitations are in applying big data as a startup. So I hope that you'll bear with me for a little bit of a behind the scenes tour. So Progenerate focuses on arthritis because it has a very large unmet need. As you can see, about 500 million people suffer from arthritis worldwide, and the annual economic burden is over $300 billion per year. And there's no cure for arthritis. So this is actually a breakdown of some of the reasons why that this is a significant disease, because it's often neglected. But as you can see, it affects people younger than cancer. It affects more people than cancer, and it costs quite a bit more money to the global economy than a disease like cancer. And one of the reasons why there is still no cure is there are more than 100 variants. So I'm telling you this because you can see that arthritis is an excellent use case for phenotyping patients and subgrouping people for stratification. Again, it has a huge impact on our daily lives. So there's a lot of incentive to innovate in this field. So about 70% of patients never return to their normal daily activity despite treatment. And so you can see there's plenty of ways that this can be innovated through disruptive technology. And there should be a very large data pool given the number of people that it affects. So the problem that Progenerate focuses on is that it's nearly impossible to predict which treatment might help an individual because there are so many patient-based factors. So as a result, a lot of people undergo a very arduous trial and error process for treatment protocols, and many don't find a treatment that helps alleviate their symptoms ever, or drop out of treatment trials because they find that it's really just not working. And they're ultimately left to wait for a joint replacement, which can take, on average, 13 years. So you can see that there are treatment categories, but there's simply no way to objectively measure which treatment might work for which patient. So you can see the setup for the personalized medicine niche. So our hardware is essentially an organ on a chip model. This means that we can simulate sort of the 3D structure of the tissue, which is incredibly important for cartilage. Cartilage is the tissue in arthritis that's least likely to heal. We can create images, as you can see on the left, looking at how the cartilage cells behave in real time. And we can also mimic some of the stress that cartilage undergoes, like it would normally in intermittent and routine repetitive movements throughout the day, which is, of course, inherent to how the disease of arthritis can propagate itself. Now you can see here that the chip is quite scalable and it works with existing infrastructure. So again, well situated to leverage big data. And this is important, again, because only about 1/3 of patients respond to existing treatments as applied. And we know that this can be increased if we can better target patients to the appropriate treatment. And Progenerate can do this with a full personalized custom analysis in about 6 weeks, as opposed to 1 to 2 years of treatment trial and error. How it works, we receive a cartilage sample from your surgeon at routine surgery. We take the cells out of that tissue sample and we actually put them into our chip where we can test different treatments, up to 6 different treatments under lifelike conditions. And you can see that this can all be done on an automated level. And we generate a targeted genomic report looking only at genes that are relevant to arthritis versus healthy cartilage. And then we basically adapt this information to send to your orthopedist, who we work exclusively with and through. So the reason I've presented this to you is so that we can see some of the basic needs for big data innovation in medicine. Now, obviously, on the company side, we are entirely dependent on our data security, not only for logistics and supply chain, but also for our patients to trust us, doctors to trust us and continue to work with us, and so that we can guarantee our compliance with international standards. Of course, reliable data security is available can be outsourced with scalable infrastructure. However, in healthcare, this still depends on a major bottleneck, on another major bottleneck, which is data privacy. So since 2018 in the European Union, GDPR is in effect, and HIPAA predated that in the United States. And this creates a dilemma between the opportunity that big data provides to improve healthcare and the right of the individual to control their own data. Also, for any corporate, but especially limiting to startup situations, this adds another layer of staff education for consent. I also want to point out, we're going to discuss this a little bit more in a following slide, but when we're looking at large-scale data for either patient stratification or personalized medicine needs, we have to be very aware of the tendency for bias in data mining. And again, this comes back to accounting for the reflections of what's going on in our social realities, our access to private healthcare, even gender has a major impact on the progression of arthritis, let alone the way that the medical chart is annotated. And this all has to be accounted for with very clean and controlled data in order to provide accurate medical phenotypes and diminish bias. Additionally, and probably most important for any startup focused on big data, and any corporate, to be honest, we cannot forget the needs of the customer, of course, which in this case is the patient. The most basic of which, how do we access the patient? What is our interface with them? And how can we optimize it? And what value adds are we leveraging big data to provide to the individual? So of course, I have an app here as an illustration, and that is an excellent patient interface portal. However, it can be a limited portal. I think one of the things that we have learned from digital medicine is a basic patient need is to feel empowered, not only to own their data, but to be able to work together with their doctor to optimize their treatments and also obviously achieve the best possible outcome. A lot of this can be done through monitoring. And what we find in digital medicine is that when we're utilizing apps and when they're cleverly leveraged, not only does this empower the patient, but it also motivates them with real-time monitoring so that they can see their own progress reflected back to them. Of course, I've already alluded to the fact that patients ultimately are seeking improved outcomes. Arthritis is a fantastic use case for this example because the amount of people who lose their ability to function in normal daily life, but also actually suffer daily pain. But also, improved outcomes are always the goal for patients seeking medical care. And if this can be simplified and streamlined in a way that incentivizes the patient, they have additional buy-in. Now, patients, of course, need better treatments. I think arthritis is an excellent demonstration of that. But in order to provide better treatments, we need more patient data on a big data level. So not only can we use genomics, like targeted gene expression in the case of Progenerate, but also having access to phenotypic data or how symptoms are progressing post-treatment can be used to drive better development of pharmaceutical novel therapies. Okay. I think that's a pretty broad overview of where we're at, where we're going, and what the daily limitations are for big data innovation in medicine. But I just want to highlight a few more open challenges before we conclude, because they are important in leveraging big data innovation for healthcare. So for good AI solutions, we still have to consider a few additional aspects. Obviously, data quality practices and the possibility for bias is huge. It's a major complication or potential complication. And we accumulate vast amount of data daily, particularly in imaging. There's more data than we can analyze at this point in time. So this requires a large amount of data cleaning, but it also requires and sets up this sort of conundrum for the need for an overview or higher up level of data quality control. So not only does this create an opportunity or requirement for auditing and audit protocols, but it also highlights the lack of governance and structure sort of on a standardized level to approach these problems. We know that the data quality, data cleaning, and also the algorithmic design are all important to prevent bias. But essentially, unless we can account for potential biases, the accuracy of the data is always going to be questionable. And when we're looking at developing novel therapeutics or improving personalized care, accuracy is paramount. So I think we can only, again, stress the need for high level and internal risk management, governance, and quality control. And then a less often discussed component of big data innovation in medicine is protecting providers as motivated stakeholders. And by providers, I primarily mean startups who are innovating medical device technology for big data, also pharmaceutical development, which is leveraging big data. Because when we're looking at acquisition of big data sets, we're primarily administering this through database structures and maintenance, right? And this can actually be patented. However, patent law for database structure and maintenance is legally in its infancy. So there's a lot that needs to be standardized, developed in this realm, but also something of really high concern is that there's currently no way to protect your database content, which brings us back to the paramount need for data security on one side. But right now, corporates can only rely on treating their database content as trade secret, which of course creates sort of this vacuum for corporate espionage. And so this is something that the industry needs to address collaboratively in order to make it a safe place for people to innovate and ensure that the impact is really being brought to the patient on an individual level for the greater good. So I think we all probably realize that the next wave of artificial intelligence applications and big data innovation is approaching much noisier, unstructured data like that we obtain in healthcare. However, before big data can be innovated for the use cases that we've discussed, as well as additional novel applications, many challenges must be overcome. Again, accuracy of the data and the algorithmic analysis of the data is of the utmost importance. And this goes hand in hand with preventing biases and quality control. Without these things, we're not going to be able to really deliver profound impact to patients and disrupt diseases that have plagued humanity for decades, like arthritis, cancer, and more. Of course, growth of artificial intelligence and big data applications in medicine have enormous potential, but they must be carefully developed to protect stakeholders by delivering quality products and service to patients and doctors, but also in order to guarantee data security, privacy, and protection of intellectual property for the people developing this new technology. So with that, I would like to thank you for your attention. And I would also like to invite you to please contact me or my co-author, Shujana Zagiva. If you have any questions, would like to look into any resources for the different statements that I've included here, or also for any networking opportunities.
Okay, so thank you so much, Judy, for your perceptive presentation. It was an informative session. I personally enjoyed so much. And thank you so much for your time and effort you took to share your experience with us. We hope to see you with us in our next conference. Thank you so much, Julie.
Thank you. Have a great day.
You too. Thank you. So, ladies and gentlemen, now we will be having a 15-minute networking break. You guys can go and have a coffee, and I'll catch up with you guys at 12:15 p.m. CEST. Thank you. Have fun.
Hello.
Hello, Laurent. How are you?
Can you hear me?
Yes, I can hear you. Can you hear me?
I'm fine.
Yeah. Okay.
Yeah, fine.
Okay, that's great. So, okay, Laurent, it's a networking break for 15 minutes, and your presentation will be starting at 12:15. So, I will introduce you at 12:15, and then you will be starting your presentation.
Perfect.
Okay, so good luck.
Okay, cool. Just one question. If I share my video, so
Yes.
will people see me while I'll present?
Yeah, sure. They will be seeing you with your slides.
Okay, perfect.
Okay.
Great. So I switch off my camera, but I will switch it on back in 10 minutes.
Okay, sure.
Nine.
Thank you. Hi, Lauren. How are you?
How are you?
I'm good too. Thank you so much for
Good
asking.
too.
Okay, so ladies and gentlemen, our presenter Lauren Pickett is here with us, who is working as a developer advocate from Google. So, Lauren, thank you so much for joining us. Can you please share your screen? Yeah, I can see your slides. Sorry. So you can start your
Okay,
presentation now, and the stage is all yours. Good luck.
perfect. Hello, everyone. Thank you for having me today. We're going to speak about machine learning, but from a very specific point of view, from the point of view of someone who's not an expert. And I'm not an expert. But despite this, I've been able to work with machine learning for a couple of years now, and this is what I want to share with you today. Okay? So first, maybe a quick introduction. So my name is Laurent Picard. Maybe you could guess I'm speaking from Paris. I'm French. You can follow me on Twitter at Picard Paris, on Medium, on LinkedIn, and so on GitHub too. I'm a developer advocate, and I joined Google Cloud 4 years ago. And before that, in a previous life, I was an ebook pioneer. So I worked on one of the first ebook devices in the world back in 1999. And this kept me busy for 17 years. So that was a very passionate adventure. And by the way, I co-founded Booking, one of the ebook pioneers. Okay. I love to start with this quote from Arthur C. Clarke, because even after a few years, this is still what it feels like when I see something new developed with machine learning. It feels like magic, right? But this is just technology. So my goal today is to scratch a little bit the surface and know what you can do with machine learning. And sometimes it will feel magic, but it will still be a technology. So what's machine learning? This is my own definition. This is how I've been using it for the last years. The input is data. So we have data, and what we want to do is understand this data and extract information out of this data. Okay. Of course, this is not the real definition. Maybe some of you are experts. Machine learning is a part of AI, artificial intelligence. And more precisely, deep learning is one of the fields that has brought most of the progresses these last years. And so most of what you're going to see is deep learning, but I'll be using the term machine learning because it's a very generic one. Okay, ML. So how does it work? So 70 years ago, researchers had the idea that maybe we could try to mimic the way our brain works with neurons, synapses. In the 80s, researchers started to really work on it, and some of them got the Alan Turing Awards last year. So it took the idea came 70 years ago, and it took 40 years for machine learning to really work. So we are trying to mimic our brain, but for that we're using many examples. And if you think about it, this is mainly how we learn. As kids, we see what our parents are doing, sisters and brothers, friends, teachers. We learn from examples. Right, and even as adults, if I want to renovate my home, I go on YouTube and I have a look at other people and they show me how to do stuff, right? And the magic there is that we manage to solve problems, and problems that we couldn't solve before or badly. Okay. So why is it possible today? Quickly, so I told you centuries and even decades of theory in this field. Of course, we inherit from a lot of mathematical and physical background. Data, we're able to process, so big data, we are able to process data in large amounts now. Let's say for the last 20 years, we have big hard drives, SSDs, we can do it quickly. But for the last 10 years now, we have access to very big computing powers, right? With big servers that we can have, or very powerful laptops. But better than that, we have higher computing power in the cloud. Okay, this is why it's possible now. So let's take a step back and see how we can benefit from machine learning today. Of course, the legacy way, you can develop expertise. You can be an expert, and then you'll deal with neural networks. But in a company, maybe you don't have an expert in machine learning, and then you're stuck, right? There are not enough data scientists in the world to fulfill the demand, right? But if you have people with developer skills, then they can use machine learning APIs. The machine learning APIs are neural networks, that models, so models that are ready to use. They have been pre-trained. They are most of the time state-of-the-art models, so you cannot do better even if you do it by yourself, by hand. And if you see in between, there's a big gap. And for a couple of years, the AutoML field has been developing and is very successful. And AutoML lets you develop your own custom private models, still without any expertise. And this is my goal in this presentation, is to show you many examples of what's possible to do today. And it's just the beginning. And you can really see the APIs and AutoML techniques like Lego bricks. You can take one of these bricks, right? You put this brick into your architecture, and then you can do something that's smarter. Okay. So let's start with the machine learning APIs. So pre-trained models that you can use right away. So if you remember my definition, you have data. The input is data, and the input can be text, pictures, videos, and even speech. So this is the Google Cloud family of machine learning APIs. Of course, maybe you're already working with another cloud provider. You can keep in mind the principles. Most of what I'm going to show you are principles and can be done elsewhere. I will tell you when there's something unique, okay? And from this data, you can extract information. You can understand what's in a picture. And sometimes the output is actually your input into a different form. Okay, so let's see examples. And I start with the vision model for personal reasons, because in the 90s, I was a student, so you can guess my age now. And at the time with my teachers, we were trying to understand what's in a picture, okay? And I had no idea that deep learning existed at the time. And at the time, what we could do was apply imaging filters. So here, a Sobel convolution filter to, for instance, extract edges. So to try to detect the difference in contrast. And so here, maybe we can tell that there are flowers. Yes, there are flowers, thanks to the color and so on. But it kind of worked. We managed to do something, but as soon as we would use new pictures, it just failed miserably. And machine learning is solving this problem. And so the first thing a vision model can do is to describe a picture to you with labels. So if I give it this picture, it tells me that the picture is about nature, flower, garden, and so on. This is the JSON stream that you get here. To give you an idea, of course, it's an API, a web API. So if you call it with the REST API, you get a JSON response. So nature with the confidence score, 95%. I'll tell you more a bit later. More precisely, it's a vision model is able to do a match between pictures. And if there's an existing picture somewhere else, then it's able to do a match and maybe tell you where the picture was taken. And here I was very surprised. So this is the same picture as before, but I changed it. I flipped it, zoomed in, cropped it, applied a color filter. And I was surprised that it tells me that this picture was taken in New Zealand. So Hobbiton movie set. This is where the Lord of the Rings movies were shot, and the Hobbit and so on, in New Zealand. And I was surprised. And actually what happened is that the vision model is able to do a match, to match this picture with the real one that I found on the web, even though it's completely different. No, not completely, but it doesn't have any pixel in common, right? A human can tell it's the same or about the same. And it gives me the GPS location of it, okay? Even more precisely, now a vision model is able to find objects and tell you where they are located. So here, this is the cast of the movies. And the vision model tells me that they are persons, right? You see the big bounding boxes here. So this is a person at 87% of accuracy. That's perfect. Even it's able to detect pants. So pants here, you see. Tops, so t-shirts and so on. And even the small person in the background is detected here. And even the ceiling lamp. So that's pretty cool. But more precisely than that, it can detect faces, right? So here, this is a 3D rendition of Gollum. So it's not a human face. Gollum was a human, so it looks like a human. And the Vision API is able to detect that. And better than that, it can tell me where what are the bounding boxes. So if I want to do a close-up, I can do a close-up here. Gives me the location of the different features, so the nose, the mouth, the eyes, and so on. And even it's able to do sentiment detection. And so what I get here is that this face is likely angry. And yes, this is Gollum. Gollum is always angry. So that's correct. And I even have more data than this, more results. I have the position of the head in 3D. If it can be useful to me, I can know whether there's something on the head, like a hat or anything else, and more image features. Okay. Another field that has been greatly and fully solved thanks to machine learning, this is OCR, optical character recognition, text detection. Many companies have worked on this. They were specialized on text detection, and it worked, but not that greatly than with machine learning. And so this is a screenshot. And if I give the screenshot to the vision model, I get the different levels of the text that is detected. So blocks, lines, words, symbols. So I get everything. And this is perfect. This is exactly what's there. It's even kind of boring. So this is really a solved problem. You can, so it's interesting to see the limits of machine learning models. There are limits. We do mistakes, and machine learning models can do mistakes. So here I apply the perspective effect, and I get the same text. The only difference is the last quotes here are detected as a single quote. Okay, but the text is the same. It's perfect. So solve problem, but the next level is actually handwriting detection, and it already works for a couple of years now. It works greatly. So here, this is a sheet of paper with the handwriting of Tolkien, and the vision model is able to give me the same results. I mean, 2 blocks, 2 lines here, and so on, the different words. And it's not perfect as before with printed text, but it works amazingly well. Here it's making 1 mistake. So here, Elven Kings, but I know it's Elven because I have some context. I have read the books. I know that there are elves there and so on. Here is giving me Elven Kings. Okay, so it's making 1 mistake. But what's pretty cool with machine learning is that it improves with time, because with every new training, with new samples, then the model converges to something better. And I can share with you, I've been trying this for 2 years now, and 6 months ago it was making 2 more mistakes. So I could see the improvement with time. Okay. And also one amazing feature. So I told you it's able to match pictures. And so it means it's able to detect entities. If you know that in a picture you have an entity, so someone or something famous, then it's able to do a match between the pictures and tell you. And so here, for this example, I took a unique picture. I had seen it only once in a Spanish newspaper. I had never seen it before. And so this is Tolkien in a forest. So I took the picture from the web, but I changed it again. I zoomed it, cropped it, and applied a color filter. So there's not a single pixel in common. And the result I get is that the best guess for this picture is that this is a picture about J.R.R. Tolkien. And I was surprised. And I even know that the context is Spanish, because This is from a Spanish newspaper. As a developer, what I got also, and that amazed me, is that I have a unique identifier here. So this is pretty cool. Instead of working with text, with a string, and there are different ways to describe people, or Tolkien doesn't have a pseudonym, but you can call him Tolkien, G.R.R. Tolkien, with dots, or just G.R. Tolkien, and so on. Here, there's a unique way to identify him, okay? And in my code, I can work with this unique ID. This unique ID comes from Google Knowledge Graph. So here, this is very unique. You know, we have been crawling the web for 20 years, and to understand what's in web pages, okay? And so we have a huge knowledge graph, and each entity, so Tolkien in the knowledge graph, is identified with this. And in the other results, I get actually I get the URL of the original picture that I used, telling me that there's a partial matching with this image. And I even get a list of similar images. So a woman or a man against a tree, or people in a forest. So it can be useful for different use cases if you want. Teachers want to check where a picture is coming from, and so on and so on, or companies wanted to check if there are copyright issues or whatever. Okay. So I told you it's an API. So you do a web request or a gRPC request if you're very sensitive to latency. But we do provide client libraries, so in open source. So those client libraries are, and I'm pretty sure you'll find one of your favorite languages here. They are wrappers around these APIs. And it's always the same principle. So I'm focusing on Python because I'm doing that also beside. But the principle is the same. So you import the module or the package, you create the client, you provide the content, an image here, and you call the feature that you want here, face detection. And that's it. You have the results right away, and you can use them. So just with these few lines, you have the list of the people. You can know whether people are surprised, and you know where their faces are located in the images. Okay, just these few lines are enough. So that's also something that surprised me and got me to develop with machine learning APIs. We'll do a demo altogether a bit later in the second part. Okay, so keep your smartphone ready. We'll do something live altogether. Okay, and hopefully fun. So we've seen what you can do with picture, and you can extrapolate what you can do with videos. It's pretty similar, but the difference is that there is an additional dimension, time. Okay, so a video intelligence model typically will give you the different sequences in a video that makes sense, and within each sequence will give you basically the same features. So we'll detect objects, we'll track objects. So of course you cannot track an object in a picture, but in a video, if the same object is moving, or if different objects are moving in the same sequence, then you'll get that, okay? And you can do a lot more. You can detect logos, you can detect persons as a whole, even get their skeletons and so on. Maybe it's easier that I show you. Oh, I forgot to tell you, I will give you one link at the end with everything inside, the slides, the demos and everything, so you can focus on the presentation. Okay, you'll have everything in the chat at the end. So let me show you this demo. It was done by Zach, my colleague from London. And here, so this is a video, and this video has been went through the model, and here are the results that you can get. You can get descriptions, so label detection. So here you know that there's a vehicle car in this sequence, a bakery there. The first one is shot detection. Of course, you can get the location of all the different shots, all the different segments of the video, okay? You can do object tracking. So here, for instance, there are many persons in the video. There's a building here. You see, building. That's pretty neat. Persons, you can do person detection. So let's move here. There are 79 persons detected in the video. So this one is going to appear here. So you see, Let me zoom in a little bit. You see the person here with the arms up. So you get the location of different nodes of the skeleton. You can do face detection, so to give you an idea. And even here you have more features. You can know whether the face has the mouth open, whether the person is looking at the camera, and so on. Are the eyes visible, and so on. So you see, and here just in a glance, you can understand very well what's in the video. You can do logo detection. So here, for instance, there's a YouTube logo, and it works and with something else. So let's take the City Bakery. Okay, so you see here there's the City Bakery logo there, a Panasonic logo. Let's have a look. Where is it? Oh, okay, in the top here. So you see, you can fully understand what you have in the video. You can do speech transcription. You'll see that you can do that directly on audio files a bit later. Text detection. Okay, so you see all the text that has been detected in the video. Okay, you see the bakery here, Jenny Lee Bakery, and so on and so on. So that's pretty cool, because up until now it was pretty hard to understand what you have in the video. If you want to do some filtering to know whether you have explicit content that you don't want to show to kids, you can ask for this feature, and here there's nothing dangerous. There's one likely here. So let's go back. Okay, it's just before, and it's because there's a lot of flesh, I guess, here, but it's just a likely, it's not a very, very likely one. Okay. So let's move on. So you see, you can understand almost everything in pictures and videos. Okay, this is the code. If you want to do an analysis on a video, just these few lines are enough. You create a client. For instance, you say, I want to do object tracking. You specify if you want to do it on the whole video or just some segments. You call annotate video, and you wait a little bit more here because it has to process the video and extract some frames, but quicker than the video length, you get the results and you can use them right away. So this is something I've done. I've written a tutorial. So this is on our Code Labs platform. If you want to see all the code and try it yourself, on Google Cloud, of course, here, then yeah, I have explained all the different features. On my GitHub also, you'll find a couple of examples of what you can do just with 300 lines of text. I will show you examples at the end. Okay. So now we've seen what you can do from pictures, videos. Let's see what you can do from text. Okay, this is actually the first field that experts worked on, NLP, natural language processing. Understand text, what is being said in the text. Okay, and so it works at different levels, full articles, chapters, paragraphs, sentences. Okay. I'm just going to show you, for the sake of simplicity, examples on one sentence. So if I give this sentence to the natural language model, first it tells me it's English. Okay, no big deal. But I have the exact syntax of the sentence. And this is a pretty hard problem because it's totally different from one language to another one. And you get the exact type and gender of each item. You even get the punctuation. I've worked in the past with specialized companies, and they never had the punctuation. You get lemma, so you can have the canonical form of some items. Okay, like in pictures, it can detect entities. So entity, remember, is a famous person or a famous object. Okay, and so here, the entities here there are three kinds. In red, I have persons. Okay, a writer is a person, a poet, an author is a person. So that's perfect. But I was very surprised here because, okay, Tolkien is identified as a person, but I get a unique ID here, and it's exactly the same as before when I had Tolkien in a picture. So as a developer, I can still keep working with this unique ID, and it will let me work with pictures, with text, with videos, and I will always be able to localize or to find the same entity. okay, without working with text. British is mapped to the United Kingdom class as a location, and the 3 books, The Hobbit, Lord of the Rings, The Silmarillion, each of them are detected as a work of art, and that is perfect, okay? You can also do content classification. You can classify your text. And this is very useful for companies who have archives. Sometimes they have scanned their archives. They've run through an OCR and they don't know what to do with it, okay? And with this natural language feature, they can actually automatically classify everything. And on this sentence, what I get is that it should be classified under books and literature at 97% of confidence, and that is perfect. Could also be go under people and society and so on with lower confidences, okay? And like in pictures also, it can detect sentiments, but in text, actually, we speak positively or negatively or neutrally about stuff, right? And so to try that out, I took a full review of the New York Times back in the time when The Hobbit was released. It was pretty positive. And I took a more recent one from a book social network from Goodreads. It's a negative one. And so I'm showing you some sentences, and what I get are scores between -1 and +1. And these sentences come from the negative review. These sentences come from the positive review. And of course, there are many neutral sentences because we most of the time speak in a neutral way. This is used by companies to understand how we are speaking about them, about their products. And they can even have trends. If they launch a new feature, they have bugs, maybe people will speak negatively for a burst of time. They will have a peak of negative comments, right? And so on. And so it's being used on reviews, automated reviews, to know and to have there are some fine tuning possible. For instance, here I could know whether we are speaking about The Hobbit positively or negatively, only The Hobbit, not the whole sentence, okay? And here, this is how to use it, analyze sentiment, and then text is very fast to process. You have the results right away, okay? Still on text, and I'll go fast there. I've never met anyone who has never used Google Translate. So this is Google Translate available as an API. It works from over 100 language, the input to over 100 different languages. So that's thousands of different combinations. It works on text, on HTML. Maybe what I can share with you is a fun fact, and it's something I learned when I joined Google 5 years ago. In 2016, I was already using Google Translate in my own company as a simple user. I was mainly translating Asian text into French, for instance, to understand if I was missing anything in some documents from Japan or from China. And it was working okay. But you could tell for sure that it was an automated translation, a machine translation, okay? And then suddenly, exactly like when I was using Yahoo decades ago and switched to Google search immediately, from one day to the next one, the results were very, very good. I was wondering at that 5 years ago, are there humans now doing the Google translations? And what happened in 2016 was that the Google Translate team switched from a statistical model to a machine learning model. And there was a big, nice bump in quality. And for 5 years, it just kept improving. Once again, if you do a new training on a machine learning data set, the model will improve. And maybe you are improving yourself Google Translate. When you use Google Translate, you have the results, and you can tell, oh, this translation is not good. When you do that, you are helping the machine learning model to improve, because it will converge to a different result. And sometimes some users even provide a better translation. And here, this is perfect because the model knows to which result it should converge, right? And this is how machine learning models improve over time. So here, it's still not the level of a professional translator, but it becomes very hard to tell the difference. For instance, we have started to automatically translate our documentation. And I had a look 2 weeks ago to do some review, and the results, there are some details where you can tell, okay, this was automated, but the sentences are perfect. They are really great. There are just some details. So this is where the state of the art, where we are now, right now. Okay. Here, if you want to use it, it's just 2 lines. You create the client and you call translate, and that's it. Okay. Now, the 2 latest APIs are about speech, both ways. You speak and you transcribe your speech into text. So the first API, speech to text, it, like Google Translate, it works on a lot of different languages and variants. What's amazing is that it works in real time. And also something I learned with machine learning, as you teach, you train with actual samples. And most of the time we have noise in our samples. When you manage to do a good training, the outcome is that the model is robust to noise. I'm speaking right now, so I'm in good conditions. But if I'm speaking on the phone, the quality won't be as good. Maybe there will be an ambulance in the street and you will hear that. That's noise, right? If my kids would be around, maybe shouting or running, that would be noise. And despite noise, we do understand each other, right? And machine learning models are able to do that. So they are robust to noise now. And they can start to do a lot more. They can provide text with punctuation. So this is something also that specialized company, I never saw one doing that. Or of course, auto-detect the language. And even if there are 2 people speaking at the same time, then we are starting to be able to separate the different speeches, and so have 2 different text flows. Okay. And once again, if you are able to understand what you have in your, are you still seeing me? Yeah. If you are able to understand what you have in your speech file, in your audio files, it means you can index them. The speech to text model is able to give you the timestamps of all the words. And so you can really have a search engine and do a search for any word, and you'll know exactly where it's located in your audio files. Okay, so here, this is another tutorial that I wrote. You'll have the links at the end. And I pronounced French poetry from Jean de La Fontaine, and it's Maître Corbeau sur un arbre perché tenait en son bec un fromage. And this is how I use that. I create a client, I call recognize with these options. So here, to go faster, I said that it's a French text, but you could remove that now. I ask for automated punctuation, and I ask for the timestamps. And I just give the location of my audio file, so my FLAC file here. And I get a very, very good result. So everything is perfect. I would prefer to have maybe some commas and so on, but I do have an uppercase, and the next sentences are separated. And the confidence is very high, so I can really trust the results. Okay, you can try that by yourself if you want. Okay, now the other way around. You have text and you want this to be pronounced. I'm pretty sure you had that wherever you live in the world. A few years ago, banks tried to have chatbots. And so first of all, that's the previous one. You had to repeat. So speech to text, you had to repeat. I want an advisor. You had to repeat a few times. It didn't understand you. And then you got the results. And still in some train stations or whatever, you can still hear that it's a concatenation of different expressions. But now with machine learning, you can actually generate speech that is very, very natural. And actually, it's very hard to tell the difference. So at Google, it's a technology that is called WaveNet. It's been developed by DeepMind. Pretty sure you've heard about DeepMind. A few years ago, they've beaten the world champion for the Go game. 2 years ago, they've beaten gamers at StarCraft. And more recently, they have learned, they got a machine learning model to learn how to play football in 3D from scratch. And here, this is the most advanced, I have to admit. I'm a bit jealous because my field is the vision. I love the vision API, but here the text-to-speech is amazing. It can generate a human voice. It's very, very natural. And better than that, it's better than real time. In 1 second, you can generate 20 seconds of speech. Okay, so here I cannot, the audio cannot be shared. My system audio cannot be heard. But so you understand, one of these samples is the original person voice that is pronouncing the sentence, and the other one is the WaveNet generation. And when we try that, we have many samples with when we try that with our colleagues, with my colleagues, we are wrong half of the time. So it means we are fooled, right? It's really the voice of the person that got their WaveNet voice. Okay, so let me show you one demo. Maybe you didn't notice which way should I do it. Let's do it in French. Okay, so I'm going to go to Google search in French. So trust me, I'm not gonna cheat, but I do it in English very often. So here, okay, I'm in French. Maybe you didn't notice, but you can actually do a vocal search. If I click here, I'm going to pronounce a sentence, but pay attention, I'm going to speak French, but with a British accent. And if there's a tourist that is going nearby me in Paris and speaks French with a British accent, I will need to pay attention. Maybe I won't understand the first time and so on. Okay. Quelle est la température à Paris? And so that's exactly what I said, but maybe a French person wouldn't have understood. I got the results in real time. Maybe you didn't see that with the bandwidth, but as soon as I start to pronounce a new word, I have different propositions. And of course, when I'm finished, everything is perfect. Of course, I heard. So this is why we have assistants, even devices or assistants on our smartphones that work so well today. We can speak to them. The speech is transformed into text. The text is analyzed with a natural language model. And then you build a result, and with the text-to-speech engine, you can hear the result. And maybe you didn't think about it because this is very, very natural. It works really great. And so once again, speech to text and text to speech is a solved problem now thanks to machine learning. Okay. So here, this is another code lab that I wrote. And with these few lines, you can generate different audio files with different accents. And it works. You can try whatever you want. It works, for instance, I can generate French or Canadian French. Here, you can generate Australian English, Indian English, British English, and American English, of course, and so on and so on. Okay, there are over 200, maybe 250 now different languages, WaveNet voices. Okay, so we've seen everything, or most of what you can do, not everything, you can do even more, but what you can do, how you can develop smarter solutions thanks to pre-trained models available as APIs, okay? But in some cases, that will not work in your company for your specific use case. So let me show you this example. Maybe it will be better to understand. If I give these two pictures to the vision model, I will get almost the same results because basically those are clouds in a sky. Okay, so I get sky, I get cloud, blue. So almost the same results because pictures are very similar. So I get generic results. But if I want to be more specific and know that I have a cirrus here and an altocumulus here, then I'm stuck. But this is where AutoML techniques enter into play. And maybe AutoML techniques can let you solve your own problem very specific problem, still without any expertise in machine learning. So how does it work? So here, this is the Google Cloud way of working. Principles are pretty much the same elsewhere. You need to work a little bit more here. You need to provide your own private training data, right? You have to build a data set. You have to provide the samples. You have to provide examples. Okay. Once you've done that, you launch a training. Everything is fully automated. I have to tell you, it's an iterative process. We are humans. We make mistakes. We need some experience also. Building a data set will become an art. Pretty sure is already. So, for instance, you launch your first training. You realize that you have some mistakes. You fix the mistakes in your data set and you launch a second training. I would say this is the typical workflow. But then you have a model. You can train two different kinds of models. So like you've seen before, a cloud model, and you'll get the state-of-the-art model, but you'll have to use it through an API. So for instance, if you want to do real-time predictions, real-time detections, you can serve an API from AutoML. And then you can, like before, you can send requests and get the results. But when you have a cloud model, also, maybe you don't want to have something running 24/7, you can also do batch predictions, batch processing. Okay, you have a lot of files. Like if you have an archives and you want to process many different files, then you can launch a batch processing, and then you'll be notified when you have the results. In some cases, that won't be enough. In some cases, you will need to be running offline or somewhere else. And then you can also, from the same data set, you can generate an edge model. Okay, edge means that you can export it. You can deploy it somewhere else. So the first thing you can do is export it with, so everything is with the TensorFlow. So you need to know a little bit about formats, but that's it. You don't need any expertise. If you export it as a TensorFlow model, then you can run your model anywhere in a container. If you export it with the TensorFlow Lite format, you can run it in a mobile application, Android or iOS. And more recently, and I was surprised, I did it, you can export it as a TensorFlow JS model also, and then you can run it in a web page. What's interesting in all those cases, is that you can export the model, put it somewhere else, run it somewhere else, and then have no connectivity, run it locally. So it means you can run it offline, okay? And very often in real time, depends on the use case. Okay, the only difference between cloud and edge models is the size and the quality. If you want the best quality, then you have to go for cloud. If you need to run offline, then you can train an edge model, but the quality will be a bit lower. Okay. Okay, I'll keep time to answer questions at the end. Okay. Okay, so how do you build a data set? So in our example, we need pictures of clouds. So we don't need thousands or millions of pictures. Just it starts to work with 100 pictures of each label. And then you label each picture, okay? So here, this is a cumulus, a cumulonimbus, a cirrus, and so on. That's it. You just have to do that. I did a pet project on my own with my kids, and I actually asked my kids to label the data set themselves. You have to be a bit careful. I'll explain a bit later, but that's as easy as it is, okay? Then you launch a training. And if you remember, I said it's an iterative process. Here, I launch a first quick training, 1 compute hour, to have an idea of the results. And thanks to that, I saw that there were a couple of mistakes. So I fixed them in my data set, and I launched then a better training, longer training, 3 compute hours. It's distributed, so it can go faster. But sometimes you can get a model in 1 hour and a half. Depends on the size of your data set and so on. And here, I have a model that is 90% precise. which is pretty good with just the second iteration. Okay, one of the tools one of the tools to know how well your model is doing is the confusion matrix. And so here, for instance, I know that my model is doing very well with 4 labels, but not that great with the AltoCumulus. And there are 2 main reasons. My data set is not that great for the AltoCumulus. So first, I have less features, but worse than that, my features are very, very similar. And so somehow, because of that, I have specialized my model to recognize some very specific types of AltoCumulus. Okay, so as I said, building a data set is like an art. It's just common sense. You have to have a diverse set of examples, as diverse as possible. If you have people, you need to have people with dark skins and light skins and so on. I'm pretty sure you've seen all these biased. So we say it's biased is not a well-balanced data set. So it can go wrong if your data set is wrong. And the quality of your model, especially when everything is automated, will be as good as the quality of your data set. Okay. And then when you have your model, you can deploy it or you can do batch predictions. And here I deployed it. I uploaded a picture that is coming from my smartphone. It has never been seen by the model itself. And it predicts at 97% that it's a cumulus, and that's perfect. Okay. So once again, I use the vision part because I really love vision, computer vision, but it works also on videos, text, and even structured data if you have tables, for instance. Okay, and you can solve a lot of known problems. You can even do your own custom translations in your company. Maybe if you work in a medical company, you have a lot of very specific terms, right, that maybe Google Translate doesn't know. You can do your own custom translation. You can do your own custom object detection and tracking in a video, and so on and so on. Okay, it's available in also in our full-fledged platform called Vertex AI. So this is a platform that is both for non-experts and experts, and you can do everything there. I did this slide because it's maybe easier to understand what you can do in AutoML today. You can classify images. So this is the problem that we're solving here with clouds. We want to say, okay, this cloud is this type, this cloud is this other type, and so on. But you can, for instance, if you want to be very, very precise, it would need a lot of work, but you can know exactly which pixel belongs to which object. Okay. One of the features that is very cool is video action recognition. If you want, in sport, for instance, you want to be able to detect a dunk at a basketball. You want to be able to detect a penalty automatically at soccer, and so on and so on. So this is really what you can do, and you can build your own private models. It's just the beginning. It's a huge field already. After 3 years, you can already do that. It was also so here all this is deep learning. This is pure machine learning. So doing regressions on data, for instance, to be able to predict something just based on data, and so on and so on. Okay. So it's demo time. So I would like, you can take your smartphones. I would like to know how you're feeling. And we're going to use the Vision API and my own custom models, custom AutoML vision model. So I made a model like the cloud classification that is able to say whether someone is sticking their tongue out in a picture, yawning, or sleeping. It's not very useful, but it's fun. Okay. So this is the architecture. I can come back to that in the Q&A at the end. From your smartphone, you'll send me selfies. The Vision API will tell me whether they are faces, and then also I'll use my own AutoML model to be able to know whether you are sticking out your tongue to me or not. Okay, so let me give you the link to the demo in the chat so that you can click it directly. Okay, so live demo. Okay, Yeah, you should be able to click it. And now let me move to the demo. You can also flash this QR code. Maybe there's a slight delay, so I give you some time to join me. And so either you click in the chat, you flash the QR code here, or you enter the URL bit.ly/demo-ml for dev with dashes, demo ML for devs. Okay. So I hope you could join me. Let me join you right now. Okay. And so here, this is my bad webcam that's on my laptop. And so first of all, you can try to, so it's using the Vision API here. You can try to trigger any motion. Okay, so here it should tell me that I'm surprised. Yeah, it works. Surprise with very high confidence. As I have the location of the nose and the mouth, I can put a mustache to everyone here. Okay, and the orientation of the mustache is also, I think I used the same orientation as the eyes. Okay, so let's try. Let's do a second try. Hey, okay, and you see, so here it has cropped up the picture. Like before, the mustache has the same orientation as my eyes and so on, is well located. Okay, so it can be useful to know that you have some objects in a picture. Now let's move to my own custom model. So if you do next, or if you refresh the page, you can do the same, but this time it's gonna call my own AutoML, and I'm not an expert. So yeah, okay, I'm a bit tired. Okay, feel free to try anything several times. So this time the mustache will have the colors of the French flag to make the difference with before. Yawning with very high confidence, that is perfect. If you want to help me improve my model, you can check this box. Oh, it's not working. Oh, I have a bug. Okay. Sorry. Try something else, as many as you like. Okay, with the tongue out, and it does work. But you could say that I'm cheating, right? Because when I built my data set, of course, I took pictures of myself, selfies of me with the tongue out, yawning, and sleeping. So let's see how it works with you, okay? So here we have happy people. Cool. It works. Surprised people. Okay, 3 of us. Sad, nobody. Sadness and angriness are a bit harder to trigger, and also people try it less. Here, 2 of us have the tongue out. Yes, it works. 2 of us yawning. It also works with the mouth open. That's what I use in the data set. People sleeping, perfect. And finally, if you remember, we can detect objects. And so here I'm showing everyone who has glasses. Only 2 of us have glasses. Okay. I think there are only 2 different persons. Yeah. Okay. Let me show you the code for this. That's it. That's it. Just these few lines. Of course, I need a picture. So the selfie is coming from a bucket when you upload it. I'm saying that I want to do face detection, but also object localization for the glasses, for instance, and safe search detection. So if ever there was a zombie coming in, the picture would be flagged as violent, and then I would blur the picture. I do the request, I call annotate image, and I have the results. And as you could see, it's very fast. And then I do my own little processing. Okay. Anyone else join? Okay. So let's move on. It's gonna be time to wrap up. So one of the tools, and something also that people don't always understand, is that there are 4 different cases. Of course, when you get results, those are the results returned by the model. And in this case, they are called positives. So the positives are the results, the detections that you get. But there are results that you expect and results that you don't expect. And this is why you have true and false positives. in the results. But when you're missing some results, then those are negatives, and it can be correct or incorrect. And this is why you have two types of mistakes: the false positives. So here we had no, everything was perfect. So we had 0 false positive. But maybe, and I cannot tell, maybe you could tell, maybe you tried something and it didn't work, it didn't provide the result you expected on your smartphone, and then in this case it's a false negative. Okay. And then when you want to use a machine learning model, I thought the anonymization with the and the cropping with the mustache would be enough. So when you use the machine learning model, there are two types. You have a threshold. You can say, okay, I want everything above 70%. The threshold that you use determines the precision. If you don't want wrong results, then you will have a higher threshold, and you will focus on precision, on quality, right? And in this case, you want to minimize the number of false positives. But if you have a search engine and you focus on the number of relevant results, then you will focus on the recall metric. It represents the quantity of results that you'll get, of relevant results. And in this case, you want to minimize the number of false negatives. Okay. Under the hood, how does it work? So here it starts to be outside of my knowledge, but what I can tell you and share. So here, this is specific to Google. Internally, we call that meta learning. We are learning to learn before launching a training. So it's a research paper called NAS, Neural Architecture Search. And so there are many parallel trainings launched in parallel, trying to find the best architecture depending on your data. This is very, very compute intense. And this is why we have dedicated hardware like TPUs, tensor processing units. We are either using GPUs or TPUs for the trainings. Something that is known to the experts is at the heart of AutoML is the transfer learning. So in our example here, that would be the Vision API that's able to detect a cloud because it knows how to detect textures, colors, and more than that. And when you provide your own data set and you build an AutoML model, you are building additional layers that specialize this model. They are called hidden layers. And this is how you can have your own private model. Okay. Another feature, the last feature that is very specific to that, and it's fully automated now, it's hyperparameter tuning. So how to reach better accuracy and in a faster way. So quickly, in the past, it was done by hand, by experts, and they would find an optimum here, for instance, or there. Now that it's automated, it's doing better. We checked that over the last decade, and it's finding the real optimum in the field. Okay, if you are an expert, it's available as internally we call that Hypertune, but now it's available as an API. It's called the Vertex Vizier API. Okay. Let me share you just this project. So I recorded. So this is my desk here. I did an object detection model. So once again, I'm not an expert, but I worked 17 years on ebook devices. And so this is a board of one of the ebook devices that I made. And here I made a data set. I always wanted to detect what's on an electronic board, but it didn't exist. So now it's too late. If you want to do some quality insurance, then that can be useful. So let me just show you how it works. So this is the webcam, a good quality webcam that has a nice autofocus on my desktop. And here I'm just moving the electronic board below the webcam. And it's able to give me in real time the location of some components. So here I'm changing the autofocus. And I didn't provide rotated images, but you'll see that at the end, it does provide me a lot of components. Okay, and it can do between 4 and 5 predictions per second just with my. It's in a web page. That's what's amazing. Okay, so quickly before I run out of time. Okay, if you want to do more machine learning, there are verticals. Vertex AI. If you want to analyze documents, there's the Document AI platform. If you want to do a chatbot and so on and so on. If you want to become an expert, then there are two frameworks you can consider: TensorFlow and PyTorch. The slide behind was done 3 years ago, and two frameworks impose themselves. So what have we seen in this presentation is the following. In hours, you can use machine learning APIs. I just needed 2 hours to do my first prototype with the Mustache demo. With AutoML, you need days. For the 2 examples I showed you, it took me 2 days to build a data set, not at once, but in, for instance, 4 half days. If you want to become an expert, a full-fledged expert, you'll need weeks, maybe months, or years or decades. Okay, the difficulty, no difficulty at all with the APIs. With AutoML, you need to build a data set. Okay, and with expertise, you need to do everything. In the links that I'll give you on my GitHub, you'll find these examples. For instance, how to generate an automated summary of a video just by knowing the different sequences. So here, this is a GIF file that has been automatically detected. You'll find my Stash Club demo. You'll find how to automatically generate animations of the objects that have been found in the video and so on. Okay, here this is a Google comic book about AI from the Google Brain team, and here it's time to give you the link of everything and more, maybe in the chat. Okay. Okay, you'll find everything there. Thanks a lot for having me today. My goal was to give you a big overview with as many examples as possible to give you some inspiration. I hope it gave you a few ideas. Feel free to tell me. I love to learn when I give ideas. I've seen one startup made by a developer. We got an idea from that. Feel free to send me any feedback, and maybe it's time, and maybe I can answer some of your questions live. I'll have a look at the chat. But if you have any question, please maybe you can speak or put it in the chat. How these ML models are tested? Yes. So this is what I told you about bias. We are taking a big care about bias and make sure that we have balanced data sets. Exactly. So that's exactly the problems you've seen. And it's still an ongoing field. Researchers are trying to detect bias to better than that, to provide explanations. So that's called explainable AI. So right now it works like a black box. So I get results, but I don't know where they're coming from. With explainable AI, and that's a feature you have on Vertex AI, you know why some object has been detected. You know which pixels contributed positively or negatively for the prediction, and so you can better understand how your model is behaving. Okay. Okay. No other question?
Hello, Laurent. You have a question
Yeah.
in the QA session, and you can answer them in the QA session.
Okay, I'll do that.
Okay, so Lauren, thank you so much for your presentation. It was very interesting and engaging. So thank you so much for being here and sharing your knowledge and expertise with us. And we are honored to have you, and we are looking forward to work with you in our next conferences.
Perfect. Have fun. Take care. Bye-bye.
Take care. Have a nice day. Bye. Okay. Hi, John.
Good morning.
Good morning. How are you?
I'm pretty good.
That's great. Okay, John, my name is Serena, and ladies and gentlemen, now with us is John Bradsett, and he's going to share his expertise. So let's welcome him. And John, you can start your presentation by sharing your screen.
Yeah.
Yeah, I can see your slides now.
Okay.
Okay,
So we're
perfect.
ready to
So,
go?
yeah, thank you so much for being here, and you can start your presentation. Good luck. Stage is all yours.
Thank you. Okay, so I'll be talking about big data serving, which is processing and inference over lots of data at real time. Okay, so I used to introduce this by talking about how organizations progress and mature in their use of data. First, when you have a organization that's not really using data, it's what we call in the latent phase. It's producing some data somehow, but the data is not really systematically leveraged for anything. For example, if you have a movie streaming site, back in the very old days, they were logging who was watching what videos, but they were not really using it for anything. Then at some point you figure out you should use this data to improve whatever you're doing somehow, right? So you take your data and use it to inform humans so that humans can make better decisions. And to stick with our movie example, you start using your view data to let humans working for you create list of popular movies for different audiences. At some point, you want to take the humans out of the loop to make this more efficient, right? And then that's when you enter the learning phase, where you take your data and make decisions from your data automatically. And this is where we get into machine learning frameworks and all the standard big data technologies, right? For example, in the movie site, you may start auto-generating movie recommendations per user segment periodically, every day or something like that, right? So that's where most of the most advanced organizations are today, apart from some of the most well-known and biggest ones and some outliers, which have entered what we call the acting phase, where you make automated decisions from data online as you need a decision to be made. For example, in a movie site, you will auto-generate recommendations for a given user in that user situation when needed by the user. So that's what the term big data serving is referring to, right? So it's selection, organization, and machine learning model inference over lots of constantly changing data with low enough latency that humans don't get annoyed while they're waiting for your decisions to be made, which typically means you need a latency of less than 100 milliseconds. And because you have lots of end users needing decisions to be made, it also typically means you need to handle high loads, so thousands of queries per second typically. So in short, it's when you combine AI, big data, and online serving. So why do you want to use big data at all? Well, in some use cases, it's necessary. Things like search and recommendation, you really need to look at lots of data, and that's quite obvious, right? But in other use cases, it's not that obvious, but we see that organizations, as they become more advanced, typically evolve to start using data a lot more in their decision making, even though it's not really crucial to create anything at all, right? And there's two ways to use data really. One is to do what we might call intuition AI, which is compressing all the data into a single function that makes the decisions for you. And that's what you typically do in standard machine learning, right? And in addition, you can do deliberate reasoning where you look at the details of relevant similar data to make informed decisions. And a good AI system really need both, right? So that's the more general case for using big data in applications. And why do you want to make decisions online? There are some advantages to this, right? You can use up-to-date information, both the data that you are computing over, like the movies and series in your movie recommendation site. You can use the latest releases, all the data that you have about them up until now when the user is entering. And you can also use up-to-date information about the user and the situation that you're deciding for, which is also very important, right? For example, in the movie site, if the user just watched something, you may factor that strongly into your next recommendation, right? And because you're only computing in real time just when you need the computation to be done, you're not wasting any computation. In contrast, if you're doing batch decision making up front, you need to compute for every situation that may arise in your next cycle, right? So that typically means that a lot of that computation ends up being wasted. And for the same reason, if you're doing batch computation offline, then your decisions can't really be very fine-grained, because then it's just too much computation and too much waste, right? So you need to, for example, if you're computing for users, you need to segment those users into groups and then compute decisions like recommendations for each of the groups rather than for each user individually. Right? And lastly, if you have a black box that can provide the big data serving functionality for you, then the rest of your architecture becomes much simpler, because you just feed your data into that black box and you issue queries to it, and that solves a lot of your architecture. So for these reasons, over time, we think that big data serving will become all applied AI. And for different use cases, it will take different amounts of time, right? For search, it already happened. For recommendation, we are, I would say, maybe 20% there. And for use cases, we are even shorter along. So if using big data serving is so great, why aren't everybody doing it? It's because it's really hard to create that black box where you just issue all your writes and your queries, and it does everything magically for you, right? That black box needs to handle mutable state, distributed computing, because all of the computation that needs to happen is too much to be handled by a single computer, right? And it needs to do that with low latency and high availability, because you're dealing with end users directly. And that's a lot of problems to solve at once, right? And that's why most people aren't doing this with. So in a little more detail, what you need is real-time actions. You need to find the data and make inferences over the data in a couple of tens of milliseconds. You need to handle data updates at a high continuous rate at the same time, because you want to stay current with what your users are doing and what situation they are in, but also changes and additions to your actual data, right? And because you're dealing with what users are doing in real time, you need to handle high request rates over all of that data. And for the same reason, you need to be highly available, which means you need to recover from hardware failures without any human intervention. And you need to be able to evolve while online, so changing data schemas, changing business logic, changing machine learning models, and even the hardware you're running on while you're online and handling the writes and query traffic. And you need to integrate with the rest of the big data stack, like handling data coming from offline data lakes and consuming machine learning models from various learning frameworks and so on. So that's just way too much work for most organizations to do on their own if they're not Facebook and Google and so on. So most organizations haven't really been able to do this, but now they can, because there's finally an open source platform that does all this for you. And that's the platform Vespa, which I'm the architect of. So Vespa is an open source platform. You can find it on vespa.ai. It grew out of the web search use case, which was sort of the canonical big data serving use case, because it's lots of data, And since it's search, you can't really pre-compute all the answers to all the queries because there's just too many potential queries, right? So you need to compute online. And to do it well, you need to use machine learning, AI, to deliver good relevance for you. So my company was competing back in the web search space back before Google came along, and we were acquired by Yahoo, where we started working on this as a more general platform for more use cases. And in that org, we made Hadoop to solve the offline part and Vespa to solve the online part. Hadoop we could open source right from the start, but that wasn't really possible with Vespa because of all the complicated IP situation around search. But we were finally able to open source a few years ago. And since then, we have been spending most of our time supporting use cases from people outside our parent company, I would say. And the core idea of both these platforms are the same. Rather than pulling data from a database or something up to a stateless computing layer when you need to compute something, you represent the computation that needs to be done in some serializable, machine readable form, and then distribute the computation to the data, because the core resource that you are running out of once you have distributed your data is really data center bandwidth to move the data. So that's the only way to really scale these kind of systems. So just some example usage of Vespa from the use cases I know the best, since they are in my own company. We use Vespa to in Verizon Media to solve things like recommendation, really personalization of content for Yahoo front page and Yahoo News and lots of other sites like that. When the user visits, we look up a machine learned representation of that user, and then we use that representation to compute the best articles, videos, and so on to show to that user on the fly, and that computation happens in Vespa. We also do this same thing for these native ads you see in here, and that we do for a lot of other sites as well. So that's probably the third largest ads system in the world, handling about 450,000 queries per second total over these systems. Okay, so that's just some example use cases. There are a lot more, but I won't really go into that. Rather, I'll talk about the more general use cases that you can solve with big data serving. So the most well-known use case is search, right? Where your data items are some kind of text documents typically. And the query is keywords that a user has typed, maybe along with some contextual information and information about that user, his location, and so on. And the machine learning models that you evaluate are relevance models, and you also select the items to return by relevance. So Vespa provides a fully featured traditional search engine where you create full text indices, typically use GBDT, gradient boosted decision tree, machine learning models, and use text match relevance features, snippeting, linguistics, and so on to provide the search functionality. So there's, over the last few years though, there has been a movement away from this and towards what some people call search 2.0, where you, rather than doing your matching and so on in token space, you embed all your documents as well as the queries coming from users in vector space and use vector similarity for retrieval, and then some kind of deep learned neural net model to compute the final relevance. And Vespa can do all of that for you as well, because it has embedded vector search functionality, as well as ability to run these machine learned models on the content nodes themselves. And you can combine both techniques at the same time and mix and match relevant signals from both and so on, which is what the very best systems do today. Another use case that's maybe now bigger than search is recommendation. Sometimes it's also called personalization, or in ad serving targeting. In this case, the data items are anything that can be recommended. Movies, articles, things you want to buy, guilds in games, and whatever you can think of. And your queries here are typically some filters saying what is eligible to be recommended, as well as representation of the user and or the context of the user. And the models that you evaluate are some kind of recommendation model, and you also select by recommendation. Here in Vespa, you do similar techniques as to the Search 2.0 features that I mentioned earlier. You can represent these items that you want to recommend, as well as the users, in a vector or multidimensional tensor space, and then evaluate machine learned models in a variety of formats directly in Vespa. And you can either use approximate nearest neighbor search or just do brute force vector similarity over all the items. Another use case that we see coming along a lot is where you want to predict something in the finance space. So your data items are some kind of assets, and your queries is an update to the birth date. And the machine learning models that evaluate are a price predictor. And here you retrieve items by the largest price change typically. So that you want to find stuff that changes a lot based on this birth date update according to your price predictor. And if you have a model that can do that, and you can evaluate it really fast, which you can with Vespa, then you can make a lot of money. Another use case we see a lot now is question answering, which is kind of using search to find snippets or passages of text that potentially answers the question, and then use a machine learning model on top of this to retrieve the concrete answer from within this ranked snippets of text. We have some use cases described where we replicate state of the art from the research in this on Vespa, but in Vespa you do it in less than 100 milliseconds, and it scales to thousands of queries per second, and you can run it in production. Okay, so big data serving, when I talk to people about it, is often confused with analytics. So just a slide on the differences we see between typical analytics systems and big data serving systems. So analytics is where you're solving problems at stage 2 in the maturity levels I showed at the start, right? Where you want to extract something from your data to inform humans that can then make decisions. So in that case, your response times can be in the low seconds or even higher, because the people that are waiting for your data is employees, and they can tolerate waiting, right? And for the same reason, you have a low query rate. And typically you are only looking at time series data, and you only append new time series items. You never really changed older data. And since you're dealing with employees, downtime and data loss are both typically acceptable. While in big data serving, response times need to be low milliseconds, you have high query rates, typically random writes, and you need high availability, right? So Vespa delivers all that, but the flip side of that is that dealing with massive data sets, trillions of documents, are more expensive than in a typical analytical solution. So that's the trade-off, right? Okay, so that was what big data serving is, and covering Vespa, which delivers these features and which you can use freely because it's open source. And now I'll talk a little bit in 5 minutes about the architecture of Vespa for those who are more interested in details. So to recap, Vespa is a platform for search and selection over structured data or unstructured text and vector data. And it can do relevance or inference over the matching data using natural language features or just evaluating advanced machine learning models directly imported from TensorFlow, ONNX, and so on. You can also do query time organization and aggregation of the data, like grouping it into groups and subgroups and computing averages and so on over the groups, which is very useful for navigation, visualizing the data and things like that. It can do this while it handles real-time writes and updates to the data at a high sustained rate, typically a couple of thousand writes per node per second. The clusters are live, elastic, and auto-recovering, so you can add nodes and remove nodes while you're handling writes and queries. And using the same functionality, if you lose a node suddenly, then the data will just be automatically redistributed over the remaining nodes. It also contains a processing logic container stateless in Java, because typically applications need to add their own business logic to implement the details of the use case. So you can do that inside Vespa, because that will be faster. And because this systems typically contains lots of nodes and processes and so on, the clusters are managed by Vespa itself. So the architecture looks like this. Vespa is a two-tier system, and every kind of big data serving system needs to be a two-tier system like this, right? So the incoming queries and write operations go to stateless container cluster, which you can have multiple of. And in those you can process the queries, process and change the documents, and do other kind of operations like that. And also the global part of the Vespa functionality itself lives in one of those stateless Java container clusters. Then we have what we call content clusters, which stores the data, redistributes the data if there are changes to the nodes in the content clusters, and also do the distributed part of query execution. And in Vespa, this is all written in C++ because it's data layer, so it needs full control over memory and so on. And lastly, we have the administration and configuration cluster, which manages these clusters and nodes and processes and so on for you. So you don't need to configure them manually, because that would be a lot of tedious and error-prone work, right? And what the end user sees is a high-level abstraction, which you call an application package, which contains your machine learning model, your configuration of what you want to run as a high-level description, and as well as any Java components for the stateless tier you have and things like that. And when you want to create a system, you just create this application package and then deploy it to the config cluster, which will then set up the system for you. And if you want to change the application, you just change the application package and deploy it again. And the admin cluster will figure out the delta from what is running and what it should be running now. And if it's safe, it will automatically migrate the system from the current state to the new state. And if it's not safe, it will reject your new configuration. So the point of a big data serving system like Vespa is to provide low latency computation over lots of data, right? And there are really three main strategies you can apply to do that. First is parallelization. So when you have an incoming query to a container node, it will be scattered to all the content nodes that have content that should participate in that computation, so that the content nodes can compute on their shard of data in parallel. On each of the nodes, you also do sharding over multiple cores dynamically, so that if one shard is finishing early, it will take over work from the others and so on. Secondly, we prepare data structures at the right time and maintain them in the background. And the canonical example here is posting lists, which we use for text search. And we also do B trees for structured data, as well as HNSW indices for vector nearest neighbor search. And lastly, we move as much execution to data nodes as possible. And there's two reasons for that. One is that that allows us to parallelize and basically grow infinitely with your data growth. And the other is to avoid running out of bandwidth between the container nodes and the content nodes. So when you have a machine learning model, for example, as part of your application package and deploy it, it will be copied to all the content nodes so that the machine learning models can be evaluated locally over the local data rather than having to send the data somewhere for evaluation. Okay, the rest of this presentation is just more details. You can find it online if you want. I don't want to spend more time than I have allocated, so I'll really stop here. If you want to check out Vespa or learn more about big data serving, you can go to vespa.ai and find lots of stuff there. So with that, I'll stop and maybe take questions if there are any.
So, John, thank you so much for your informative and stimulating presentation. And thank you so much for your time and effort you took to share your experience with us. So thank you so much for being here. And you can, I'll ask the audience that if they have any questions, they can ask in the QA session. Thank you for your time and looking forward to work with you in next conferences. Thank you. Okay, so ladies and gentlemen, our next presenter is Camilio Mercy from Absa Bank, and he's the country head of data management at Absa Bank. And we are going to play his presentation and stay connected. Thank you.